Sir?
Yes.
Just I had a doubt. Can I ask it now?
Yeah, yeah.
Good evening, sir.
Good evening.
Good evening, sir.
Good evening.
Sir, today which weeks are covered?
Uh, 8 and 9.
Okay, sir. Thank you.
Sir, do you take week 10 and 11 also, revision season?
Course instructor will take 10, 11, and 12.
Okay, sir.
So I have a picture it in the chat.
Yeah, yeah. So basically, what is the question? If
Uh,
L is the minimum value of the function f, then find the value of at L. What is the function?
so I have a patient. Sir. The next one is.
Okay. So what is the problem in this question?
I'm unable to understand, sir. How to.
Okay. Okay. This thing I will take further. Okay, because I did not explain what is minimum and what is maximum yet till now.
Okay.
So when I will discuss about it, maximum, local minimum, I will take this. Okay, sir, can you please share yesterday's note? Yes, yes, I will share. Just message me on my Gmail via chat box. I will share the notes. Okay.
Sir,
So
just a
here I am pasting some trigonometric identities. Please take screenshots.
Uh, Sir, just a simple
Yes.
question. If you want to find the edges in the graph,
Mhm.
we have to multiply with the vertices and minus by 2 now. There was some
Sorry,
question.
I did not get your
Uh,
point.
2 the question. Then if the number of vertices are 5, sir, what will be the number
Okay.
of edges in that? Like it will be like vertices multiplied by 2 and minus by 2, like it was.
This is
I
the question
remember.
of graph theory, right?
Yeah, sir.
Yeah.
I'm just asking because I was getting stuck in it.
Actually, I did not done that graph theory part yet.
Okay, yes, sir.
It was not in my syllabus, so I don't have any idea about it. Yeah, you can ask to another instructor for that. That is why I am not taking your revision session for week 10, 11. Okay, here is some trigonometric identities that will be helpful for you for your exam purpose. Here pi by 2 means 90, okay, and 2 pi means 360, pi means 180. Okay,
Yes, sir.
just take a screenshot. Sir, can you please tell the weightage for all the weeks?
Sir, I posted a short question on top of it.
Hmm. Right? Hmm. Just a short question. Infinity by infinity allowed in L hospital rule or the shine? We will discuss, okay? We will discuss about it.
Okay, sir.
Okay, 3 more minutes. So we will wait for 3 minutes and then we start. Sir, please solve mock test. Today it's I don't think so it is possible. First, we have lots of things to discuss in week 8 and week 9. Firstly, limit continuity differentiability. It will take lots of time. Yeah, TS are taking notes. Yeah, you can join that session as well. Manish?
Yes, sir.
Uh, some question previous PYQ session are also running, I guess, right? It was around 6 to 8.
Sorry, sir. Can you scroll down the screen just a little bit?
Yeah. Right?
Yes, sir. Just let me take a screenshot. Done, sir. Thank you.
Will there be a class for PYQ? Yeah, there are some classes, right? Which is scheduled for PYQs only, some TA session kind of thing. Today it was around 6 to 8. There are some sessions which are simultaneously running for
That was
PYQs.
for PYQ.
That sessions are also recorded or no?
It
They are
it is
not recorded.
recorded, but they
It will be
discussed.
recorded.
Yes.
So, no issue. You can watch after
But
this
I
class.
think that one is over now.
Mm. It's over, right?
Yes, sir. I think so.
Okay, so what we will discuss today. Okay, so let's start the session. Sir, when will you take week 11, 12 revision session? I will not take week 11 and 12 revision seconds. Some other will take that sessions. Okay? Or no?
When?
Sorry?
When?
That I don't know right now. But whenever the session will schedule, they will inform you, or you can see your calendar as well. Okay. Which notes are you talking about? Yeah, yeah. I told you, na. Just message me on my Gmail. I will share all the notes.
So can you show your mail
Okay.
ID?
Yeah. Just a minute. I have pasted. You can see.
Yes.
Okay, so let's start the concept of limit. Okay. Okay, so basically what we have discussed till now, we have discussed some functions and all, the properties of function and all. But basically what today's agenda is, we will discuss about limits, continuity and differentiability. Okay, so for limit, we have already discussed the concept of sequences and the limit of a sequences, right? Limit of sequences. So sequences, what is sequences? Sequences is nothing but it's a function from natural number to R, right? Right? And what is limit? So for limit of a sequences, say an is a sequences, then we will say A belongs to R, a real number A is a limit of an, when we will say if as n goes to infinity, our an will go closer and closer to a, right?
Yes, sir.
Right? That was the definition. So what does it means graphically? Graphically it means suppose this is your sequence an, okay? So whenever you will take n as goes to infinity, and if here a is here, then in this short interval here, so many like here there are so many elements of this an will lie, right? Right? In this interval there will be lots of elements of an, right?
Yes, sir.
Or this an will go to closer and closer this way, either by this way or by this way, whatever it is. But whenever I will take n larger and larger, your an will go to closer and closer to a. Or you can say whenever I will see this value will approaches to 0. Right? If an will go to closer and closer to a, it means that the difference between an and a will decrease, right?
Yes, sir.
Right? The distance between these 2 points will decrease and will decrease. It means that it will go to 0, towards 0, right?
Yes.
So that is the another way to see whether this thing is a limit or not. Okay. So before starting the limit of a function at a point A, okay, at a point A, we have to know about some concept about what is left hand limit, what is right hand limit. Okay, we have to bit idea about it. What is that? Then only we will discuss about this limit portion. Okay, so what is left hand limit of a function? Suppose this is the graph. This is a nice graph of your function, and you want to calculate the left hand limit for this function. So what is it means actually? It means that, see, here if your input value, suppose your input value are coming x, your input value is moving towards a by left side. Right? What I am saying? I am saying if your input value are moving towards a by the left side, so simultaneously your output value will go somewhere else. Like I don't know where, but it will go somewhere, right? Why so? Because your function f is defined from your domain to R. Your f is defined in this domain, right?
Yes, sir.
Function is defined. It means that if I will take this x value, there will be some output value.
Yes,
Right?
sir.
Now, in this case, we have to discuss about that output value. Where that output value are going actually. Okay, whether that output value are moving some point, whether their output value are going towards infinity, whether the output values are oscillating, whatever it is, we don't know about it. Okay, right till now, but we will discuss about it. Okay, so now, just a minute. Okay, so what is LHL actually? What is LHL? So let me write the definition first.
Left hand
Let,
limit.
yeah, left hand limit. Left hand limit of a function at a point A. Okay. So what? Let f be a function. F be a function and A be a point such that there are some an in your D such that an converges to A. Okay. I am taking this point A such that there are some sequences in D. Means that there are some sequences in D such that that sequence will converge to this A. Okay. Why I am taking this kind of point, I will let you know later. Okay. Now, if there is a number L, I am taking this definition from your class notes only. Okay. There are some more definitions, some other definition of left hand limit as well, such that Fan goes to this L for all sequences. Sequences An goes to A. Then we will say this L is the LHL of function at A. Okay. What does it mean? It means that suppose here you have a point A, and what you are seeing, whenever you are approaching by this way to A, your functional value is approaching towards L. Suppose this point is your L. What I am saying if this is your functions graph. Okay, this is your functions graph, and here is your point A. So here I don't know what is it. Here function is defined or not, that thing I don't know. But this point is, I am saying this point is L. So let's remove this point from here. Okay, suppose here function is not defined, and here this point is your L. Why I am saying this is not defined, I will let you know. Suppose this A is not belongs to your domain. Okay, A is not coming from domain, but A is such that here there are so many points, like there is a sequence such that this sequence is converging to this A. What kind of point I am taking? I am taking those point A such that there is a sequence in D which converges to this A. Okay, this kind of thing I am taking. Why I am taking, I will let you know. Now see, whenever I am approaching towards this direction to A, as you can see, your functional value is approaching towards L, right? In this case, right? Am I audible or no?
Yes.
Yes, sir, you
Am
are
I
audible.
am I audible, right?
Yes, sir.
Yes,
So
sir.
what I am saying, suppose I have taken this point, okay? I am getting this value. Suppose I have taken again this point. I got this value. I have taken this point. I got this value. Now I have taken this point. I got this value. So what I am saying that whenever I am going towards this A, this functional value. Suppose this is some x1. This is some x2. Okay, this functional value going towards L in this particular case. So whenever this kind of thing is happen, then we will say this L become your LHL, left hand limit. Okay, understood? Okay, so why I am taking this sequence kind of thing? Because I am not able to see in a connected way, right? Because I am not able to see in a connected way. I cannot take each and every points and then see where this functional value is approaching. So for that, I am taking some discrete point which are going towards A in the left direction, by the left direction. Here, one more thing you have to take. Here, this AN is less than A. You are getting my point? For example, this is your function. Okay, this is your function. This is your function, and here is your point A. Now, suppose this value is your 1, this value is your 2, and so on, whatever it is. And this is some A. So what you are saying, for this function f, whenever you are approaching towards A in the left direction, whenever x is approaching towards A by the left direction, your fx is approaching towards 1, right?
Yes, sir.
Right? Your fx is approaching towards 1 in this case. Now, suppose here, but we don't know about it whether this fa is equals to 1 or no. We don't know about it, but here is one value 1, where whenever I am approaching this a towards left direction, your functional value is approaching to 1, right? Then in this case, this 1 will be LHL at x is equals to a. Okay, you
Sir, but
understood the
f of
definition?
a equals to what? Not defined, na?
Yeah, this is not defined. We don't know about it. That's what I am saying. We don't know.
Okay.
Okay, just a minute. Okay, so what is going on here basically? Basically, I know here I have some domain D, and here is one point A. So what is my interest? My interest is whenever I am approaching by this direction, where my function is going actually. I don't know whether at this point function is defined or not, but I am interested only on where the function is approaching. Suppose your function is approaching towards L. Okay, by the left direction, it's approaching towards L. It means by the left direction, it means I will take some points from here, like this, and I will see the functional value of at this point, and then I will see where this functional value is going actually. You're getting my point? So if I will see this thing by the left direction, then I will say, yeah, I am continuously seeing for the left hand value, left hand limit. Okay, so if this L exists, what do you mean by L exists? It means that there are some functions like 1 by x. Okay, this kind of function it is. 1 by x. At this is 0. So this is 1 by x. So just see, whenever x approaching towards 0 by left side. Okay, so by left side, this will be I denoted by this minus. Okay, 0 minus. For the left side purpose, I will denote this by 0 minus. It means that I am approaching this 0 by left side here by this way. So as you can see, your functional value fx is going towards in minus infinity,
Yes,
right?
sir.
And minus infinity is not a real number.
Yes.
It means that for this case, your L does not exist, right? So we will say whenever, so this implies your left hand limit does not exist at 0, right? Right? If you have
Sir,
some doubt, please
left hand,
ask.
yes, sir.
Mhm.
Left hand limit, so here difference does not exist means that we can find left hand limit anytime, but it exist or not exist is a different thing, na?
Yeah, we cannot find left hand limit every time. Okay, because for this case, we don't know what is left hand limit. It is going towards minus infinity. It is going small and small and small. Okay, we don't know about it for this case.
But for say before examples, we find the left hand limit which are not defined at f of a like that.
See, you are seeing your fx is continuously decreasing, and it is going towards minus infinity. It means that your L will become minus infinity. It means that your L does not exist till now, because L is not your real number. So in this case, we
Okay.
will say your left hand limit does not exist.
Okay. Okay. Yes,
Okay.
sir. Yes, sir. If
Okay.
sir,
If you are getting some finite value,
okay.
okay, then you will say, yeah, your left hand limit exists.
Okay, sir. Sir, that finite value can be defined at the f of x or not defined at the f of x, na?
Yeah.
Okay,
That
okay.
value can be defined or
Or not
cannot be
defined.
defined.
But
Okay.
then LHL is LHL exists.
Yeah, exactly. LHL will
Okay,
exist.
okay. Yes,
Just like
understood.
for example, I will give you an example 1 0, where x is greater than 0 and x is less than 0. Okay, I am not saying here what is the value at x is equals to 1. Okay, so for x is equals to 1 for this. Okay, let's take this. So what is this actually? For less than 0 case, you are get this is your function.
Yes, sir.
Okay, here functional value is your 1.
Yes, sir.
Okay, means that
Yes, sir.
f of 0 is your 1. Now in this case, if you will see, as x goes to 0 minus mean if I am going towards 0 with from the left side, then your functional value fx is going towards 0 only.
Yes, sir. Yes.
You can see, but
Yes, sir.
f0 is equals to what? 1. f0 is equals to 1 now.
Yes,
See,
sir. Yes. Yeah.
see. So what you are getting as your left hand limit and what you have as functional value, both are totally different to each other.
Yes, sir.
Okay, so
Yes, sir.
we are not worried about it whether the function is defined or not at that point. If they have given me what is the functional value of this, then
Yes.
we are not worried about it. Okay,
Okay, sir. So here's a left hand limit exists, na?
just a minute. Okay.
Okay, sir.
Yeah, in this case, left hand limit exists. Why so?
Okay. As it is getting the defined value 0.
Yeah. Amit is saying something. Amit is saying let f is a function from a to b. where A and B are finite subset of R, which of the following options are correct? The cardinality of graph of F same as the cardinality of A. No? First one is incorrect. It is incorrect because it depends, right? Yes, I guess it is correct. If F is a function, then it is correct. The cardinality of a function of graph A. So what is graph A actually? AF of A, right? Yeah, you are right. It is correct. The cardinality of graph A is the same as cardinality of A. Why so? Because how many outputs you can take? The maximum number of outputs you can take, number of element in A, right? So how many pairs will be there? Suppose, okay, for your viewer, I am solving this Amit's doubt. Okay, so he is saying, suppose f is your function from A to B, then he is saying, suppose this is your graph. How it is defined? It is defined as like this: x fx, such that x belongs to A. Then he is saying the cardinality of the number of element in this graph is same as number of element in it. Okay, so this is correct. Why so? Suppose you have 4 element, 1, 2, 3, 4, and here you have A, B. So what will be your graph? Your graph, suppose A is meeting to this A, this is happening here. So what will be your graph? Your graph will be 1A, 2A, 3B, and 4B only, right? Because this number cannot repeat. One input will come only once in a graph, right? So the cardinality of graph of A will be equal to cardinality of A. Okay, so let's do not. Okay, so you understood the concept of left hand limit.
Yes, sir.
Okay, similarly you can see for right hand limit, RHL. So for RHL, what is the condition for RHL? In this case, we will move towards A by the right direction. Okay,
Positive direction.
not positive direction, but right direction.
In RHL, we can use the zero approaching.
Yeah. So in this case, we will see if I am approaching towards A by the right direction where my function is going, same as LHL. So suppose if your function fx is approaching towards L, as x is approaching A in by the right direction, then we will say your RHL at A will be equal to L. Got it? Got it? No rocket science here. What you have to see, just you have to see for left hand limit, if this is your A, for left hand limit, just go towards A by left direction and then see where your fx is approaching. If it is approaching towards L, and if your L is finite, if L is your real number, then we will say this L become your left hand limit. And for the right hand limit, if you are approaching towards A with the right direction, and then if you are able to see if your function value is approaching towards some finite value L, then we will say or some real number L, then we will say this L will become your right hand value, right hand limit. Okay.
Yes, understood.
Okay.
Yes, sir.
So yes. Yes. Okay. So what is limit actually? So this is a
X
definition.
going
Okay,
to
this is
0 plus.
just a definition. Okay, so before starting this, I will write how will you represent this LHL. So this LHL is represented like this: limit x tending to a minus fx is equals to L, and for all HL, for RHL, we will say limit x tending to a plus fx is equals to L. Okay. Okay. So when this limit exists at a, we will say limit exists at a if your limit x tending to a minus fx will be equal to limit x tending to a plus fx is equals to L, and then we will, in this case, we will write this is nothing but limit x tending to a fx. Got it? If the left hand limit at a point A and right hand limit at a point A will be equal to each other, then we will say the limit of this function at point A exists.
Yes.
Sorry, Amit, can you unmute yourself and then speak? What do you want to say?
Hi, sir. Hi. So my
Hi.
question was a function that is from R to R. First R is
Yes.
x and the next R is fx. How is that not a sequence?
No, it's not a sequence, because for a sequence, I need some pattern for which I can put my elements, right? For the position, I need some pattern, and that pattern only given by natural number only. Or you can say integers, but I need some countable set from that. I need to assign the position for each number, right? Right? How can you assign some number? How can you assign a position by half? It's not possible, no?
Yeah, makes sense. Yeah.
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 Understood? Okay, so limit is clear to all.
Yes, sir, clear.
Yeah. If not, it is nothing actually. So there are some functions. Suppose fx is equals to x square. So at x is equals to 1, what will be the left hand limit?
1.
Limit x tending to 1 minus fx will be what? 1 only. And what will be the right hand limit?
1.
1. Then the limit is
Limit exists at 1.
equals to 1. Okay, but one caution is there. What is the caution? Caution: don't put directly x is equals to a in your function. Whenever you have to find the limit at a, when we have to find the limit at a. Okay, why so? If I will give you the example, so suppose x square minus 4 divided by x minus 2 and limit x tends to 2. Okay, so in this case, your function is fx is equals to this x square minus 4 divided by x minus 2, right? What is the limit at 2? If I will put directly 2 here, so you will get 4 minus 4 divided by 2 minus 2, which is 0 by 0 form, which is undefined. Right?
Yes, sir.
So please don't put in this case. So in this case, firstly, we will calculate what? Left hand limit. 2 minus x square minus 4 divided by x minus 2. Okay. So it is here suppose 2 and you are moving towards 2, but you are not putting exactly 2. It means that your x minus 2 will be not equal to 0. Right? You are moving towards 2 by the left direction, but you are not putting exactly x is equals to 2. You are
Yes, sir.
getting my
Yes.
point?
Yes, sir.
It means that it is not equal to 0. It means that if I can split by x square minus 4 by this manner, sorry, 2 divided by x minus 2. So I can cut these two things. Why I can cut? Because this x minus 2 is not equal to 0. Right? If it will be equal to 0, then this case will be right. And we are not able to, we will not be able to find the limit, and we will not be able to find the value of this, right? But in this case, your x minus 2 is not equal to 0. That is why I am able to cut this denominator and numerator term. Right? Now, what I will get further? Limit x tending to 2 minus x plus 2. Okay. Now, what will be the value? 4, right? Here I can put, because here there is no such issues, that kind of issues, right? So here I can directly put x is equals to 2. Got my point?
Yes, sir.
Okay, so what will be the left hand value? 4. Okay, similarly, can you please calculate the right hand limit?
So 4 only.
4 only, right? It will be 4 only. So what will be your limit?
4, sir.
Got it? So in this case, you have to make a form, because I am not directly putting x is equals to 2 here. Okay, so I am moving towards right direction, I am moving towards left direction, but the denominator term is not going towards 0. It means that it is going towards 0, but it is not exactly 0. So I am able to cut the numerator and denominator term. Or so after removing that particular term, I got this kind of term where I can directly put the value, and that value should be defined. Got it? So in this case, please be aware about it.
Sir,
Okay.
I have posted a short question about sequence sequence. Can you please look into it in the chat?
Which one?
Second
Sinu,
last one.
right?
Yes, sir. Yes, sir.
An into Bn may converge even if An.
Like this is a true statement.
Yeah. It is saying An into Bn will converges to some point L, even if one of the sequence will not converge.
So neither of them actually.
Yeah. If someone is not converging, then suppose you have, what it is the saying exactly? Suppose you have An is 1 by n. It is going towards 0, right? Right?
Yes, sir.
And your Bn is your minus 1 raised to power n. This is not a converging sequence.
No, sir.
Whenever now this is not convergent, this is convergent. But if you will multiply this two, you will get minus 1 raised to the power n divided by n. But this is converging towards 0.
So, but in the in the statement, both of them are not converging, an and bn.
Okay. If both of them are not converging, okay, let's see. Suppose An is equal to minus 1 raised to the power n, Bn is equals to minus 1 raised to the power n. In this case, what will be your A? This one? This is a convergent sequence.
Yes, it is, sir. So,
right?
but 1 raised to power infinity is like undefined, right? No?
But it is not infinity, right? N is going larger and larger, but it is not exactly infinity. N is moving towards infinity, but it is not infinity, right?
Okay, sir.
It is not exactly infinity. We are taking larger and larger value of N, but we are not directly putting infinity. And what is infinity actually? We don't know about it. Okay.
Yes, sir.
So this is not infinity. We are moving towards infinity.
Got it, sir.
Okay. Okay. Now the next thing is the limit. Here we have seen when I am going towards some finite value A. Now what if when I will go towards infinity? The limit as x move towards in plus minus infinity, plus infinity or minus infinity. Okay. So for first case 1, when x moves towards infinity. So what will happen in this case? Suppose this is your function f. And your x moving towards infinity. It means that there will be some value m. For that x will lie, like there will be some value m for which your x is greater than 0, x is greater than this m after some time, right?
Yes, sir.
Right? If x is moving towards infinity, it means that there will be some finite positive number. For that, your x will be greater than for that number. Why
Yes, sir.
that number? Right? Means that there are so many elements, so many elements in your domain D, such that your x is greater than m after some time. If x moving toward infinity,
Yes.
right?
Yes.
Right. So if you will take x goes to infinity, and for this case if your fx goes towards some finite value L, then we will say your limit as x tends to plus infinity exists. Okay, if this L belongs to R, then we will say limit at plus infinity will exist.
Sir, I have a
What?
question. Can I ask?
Yes or no?
In the tutorial, in the videos, the sir is telling for if we are checking the limit for a function, then all sequences should have limits.
Yeah,
Whereas
both things are same, right?
no
Here
for
you are moving in a continuous path. Here you are considering all the value. Basically, suppose this is your road. Okay, this is the road, and you have to move from this A point to this B point. If you are a person, how will you move? Your one step is there, second step is there, third step is there, fourth step is there, and then you will go towards B, right? It means that you are taking some points, right, in this path. Consider it as sequence.
okay, sir. But in one previous video, he's telling
Now,
some sequence it has to the limiter has to exist for the previous.
no, for all the sequences which are moving towards infinity, it means that for all sequences that are diverging to infinity, and that particular sequences, if you are functional sequences, it means that if this an is diverging to infinity, then your f an is moving towards this L, then we will say yes, this L will become your limit at infinity of this function. Okay, that was that statement, right? So that's what I am trying to explain. So just listen to me carefully by this example. Okay, so for me, if I want to move from here to here, I will go by discrete way, right? I will take one step here, 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 and one step here, and then I will go. It means that if I will say this is my A1, this is my A2, this is my A3 and so on AN, it means that by the sequence I am moving towards B. You are getting, Swarnam?
I understood. Okay, this is for limit of a function, but limit of a sequence, he's telling some sequence should have a limit like that he's telling. So what is the difference between limit of a function and limit for a sequence?
Okay, that's what I am saying. That's what I am saying. Just take a look. See, I am here. Firstly, I am relating both the definition that you have concluded by the sequential way and by this continuous way. Okay. Then I will say solve your doubt. Okay.
Okay, sir.
Okay. Now in the same path, this is the point. If some snake has to go like this, if this is your snake, my drawing is too bad. This is snake. How will this person, like how this snake will go towards B? Can this snake will go by this step direct way?
No, sir.
No, right? It will be moved in a continuous path.
Okay, sir.
Like this. This way only it can move, right?
Yes, sir.
Right? That's what going on here. That is exactly going on here. If I want to know by the sequential part, it means that I am taking like this, and moving towards infinity. Now, if I am directly saying if x goes towards infinity, it means that I am taking that continuous way. So both are same.
Okay, sir. Okay.
What is my agenda? My agenda is moving towards infinity. How I am moving? That's not necessary, right?
Now I understood, sir. Thank you.
Understood?
Yes, sir. Thank you. Yes.
Okay. So what is sequence is saying? Sequence is saying whether you are taking some points, some discrete points from this sequence, and according to that point, you are moving towards infinity, for which your functional value of that sequence will move towards L. So that is what I am going here, right? Here I am taking all those points. Okay.
Okay, sir.
Okay. No. Understood? So understood the concept of moving towards plus infinity. Okay, let me give you the example. You have seen this 1 by x example. Okay. So whenever x moving towards infinity, it means that whenever I will go by this direction, your functional value moving towards 0, right?
Yes, sir.
Right? So we will say limit x going towards infinity of fx is equals to 0. So 0 will be your limit at infinity. Got it?
Okay.
Now, similar for minus infinity case. How it is similar? In the similar case, if your x moving towards minus infinity and for which your fx moving towards L, or you can say for all the sequences an in your D which are diverging to minus infinity, for that sequences, if you are fn moving towards this L, for all sequences, those are the sequences which are diverging to minus infinity. For that, if your functional sequences will go towards L, then we will say this L will become your limit, at minus infinity. Okay, then we will say your limit x tending to minus infinity of fx is equal to L. Got it?
Okay, sir.
Got it? Okay. Why this sequential part will helpful? Suppose fx is your function, okay, and you are getting a sequence an for which this suppose your an is converging to a, okay, but for which your f an is not converging to this a.
Oh,
Sorry,
is it
not
possible
converging
to
to
give
this
an
L,
example
not
like that?
converging. Yeah, not converging to L. See.
How, I mean, can you please give an example, sir?
Just a minute. My laptop is not working. I will conclude by example. Suppose you have this example 0 and 1, where x is coming from q complement, it means irrational number, and here x is coming from rational number. Okay, sorry. Now, in this case, at 0, I am talking about at 0. So my claim is limit x tends to 0 of fx does not exist. Okay, how will I prove this is not exist? So just see, if some L is a limit, if some L is a limit, it means that for all sequences an which are going towards 0, your f an will go towards L. Right?
Yes, sir.
Right? Okay. Now, see, just take a sequence an is equals to 1 by n. This is going towards 0. Right?
Yes, sir.
What about your f 1 by n? F of 1 by n? This is a rational number, right?
Yes, sir.
So for all the rational values, your functional value is what?
1.
1. It means that it will become your 1.
Okay. Okay, sir.
Right? So your f of an is converging to 1.
Okay, sir.
Now, there is a possibility that this L which L will be equal to 1. Okay, there is a possibility. But let's see another sequence Bn, because I am saying for all sequences which are going towards 0, for that this sequence will equal to 1. This f of an will equal to L, right? So I have taken to a distinct sequence which is root 2 by n. Now this root 2 by n is your irrational number.
Yes, sir.
What will you get in this sequence? Root 2 by 1, root 2 by 2, root 2 by 3, right? This all the root 2 by 3, this all the numbers are irrational, right?
Yes, sir.
Right? But in this case, this is also going towards 0, because
Yes.
as n will go to large and large, this will go to small and small, and this will
Yes.
go to closer and closer to 0.
Yes,
Now,
sir.
when you will calculate f of bn, which is f of root 2 by n, which will equal to 0, because this is an irrational number, and in the case of irrational number, your functional value is 0.
Okay, sir.
Right?
Yes, sir.
So it means that in this case, f of bn is going towards 0. But what was my statement? My statement was for all the sequence an goes towards a, your f an will go towards L only. But here 1 and 0 are totally different. For two distinct sequence, you are getting to different limit.
Yes, sir.
It means that your limit does not exist at 0. Got it?
Okay, sir. Now it is very clear. Thank you, sir.
Right? So this sequential, this criteria is known as sequential criteria. That I will be cover like that I have to cover in further, but I'm just explaining now only. Sequential criteria for being a limit. For limit. Okay. So this criteria is saying for L. See, this is not the formal way to write, okay? I am just writing in a more explanatory way or more forward way only. So L be the limit of f at a if for all sequences, say an converging to this a, our f of an will converging to L. It means that what are the sequences, no matter what are the sequences I am taking, if that sequence are converging to L, your functional value Fan will converge to L only. Okay. Now, if I am getting two distinct sequences, say An and Bn, such that An and Bn both are converging to A, but your f of An converging to L1 and f of Bn converging to L2 by this like this case, then and L1 and L2 are not equal to each other, then we will say limit fx at A does not exist. Easy. So this criteria we will use when we have to discard the statement that limit exists. Okay. If I am able to find two distinct sequence which are converging to A and for which functional sequences are not converging to same value, then we will say this sequence is divergent. Sorry, the limit does not exist at A. Got it?
Okay.
Yes.
Okay. Okay. Disa is asking, sir, can you please explain converging case once again? So converging, now you understood, Disa?
No, sir.
So what case, like a convergence of a sequence or this limiting case?
Sir, can you explain both?
See, convergence of a sequence, it means that when n increases toward infinity, if your an goes towards some finite value, say L, then we will say this an is converging to L. It means that this an is going closer and closer to A. Closer and closer, it means that the distance between an and L will decrease. It means that the distance will go to 0. Got it?
Yes, sir.
Right? You are not getting, right?
Yes, sir.
You are not getting. So what is it means? It means that suppose you have example of 1 by n. In this case, whenever I will take large and large n means suppose I am taking n value is crore, 10 crore, arab, 10 arab kind of thing. It means that I am taking so large value of n. You can see this value will become smaller and smaller, smaller and smaller. It means that this value will move towards 0. So in this case, we will say this 1 by n sequence will converge to 0. Right?
Yes, sir.
Yes, sir.
Got it? Now, what is sequential criteria of limit is saying? It is saying if you are able to get to distinct sequence such that this both sequence converging to this A, and for that your Fan converging to L1 and Fbn converging to L2, but your L1 is not equal to L2, then you can say limit x tends to A of fx does not exist. In this case, you don't need to check the left hand limit, don't need to check the right hand limit. Directly, you can say if you are able to find two distinct sequences, for that this L1 and L2 are not equal to each other, then you will say fx at x as x tends to A does not exist. Got it?
Yes, sir.
Okay. One more example I will take. Suppose this is your graph. Okay. Suppose fx is equals to 0 and 1 when x is greater than or equal to 1 and minus 1, and when x is less than 0. Okay, so in this case I will take this sequence at 0. Okay, at 0 I am talking about. So in this case, if I will take 1 minus 1 by n, it means that I am taking this kind of step in input. This will go towards 0, right? Right, Disha?
Yes, sir. Yes, sir.
So for that, minus 1 by n, this is negative. This will be always negative, right? This will be equal to minus 1.
Yes, sir.
Yeah. It was till 12 o'clock. Yes, Sanaj. We don't want to make that class. We did not want to make that class so longer, but we cannot do anything. Okay. So it means that this sequence converging towards -1. Now, simultaneously, suppose this is your an, okay? Simultaneously, if I will take this another sequence 1 by n, this is also going towards 0. Now, if you will see f 1 by n, now this is a positive value. It means that the functional value will become 1 only. So this will equal to 1. Now,
Yes, sir.
you are getting to distinct L1 and L2 because -1 and 1 both are not equal. It means that limit x tends to 0 of fx in this case does not exist. Got it?
Yes, sir.
Okay, Sanaj. Sorry. Now I pronounce correctly or not?
I think it's Sanj.
Yes, sir. It's
Sanj.
Sanj.
Okay, Sanj. Okay, Sanj. Sorry. Okay, then understood the concept of limit. How will you check the limit exists or not? So there are two ways. Either you can directly go by that left hand and right hand criteria, or you can go by this sequential term. But if you want to, okay, Sanj. Okay, fine. Sorry for that. Okay. So sequential criteria when I will use whenever I have to discard the statement that limit exists. If I want to show limit does not exist, then I will go for sequential criteria, right? For proving the limit, I will use that LHN RHL criteria. Why I will not use this? Because I am not able to see each and every sequence because there are infinitely many sequences. If I will see one by one, it will take lots of efforts and time as well. Okay. Okay. Now, continuity. Of a function at a point A. So this is nothing. If your limit x tends to a fx will equal to f of a, then we will say this function is continuous at A. Easy?
Yes, sir.
Yeah, I will share in the last end of the class. Okay. Okay, Arun. Easy, right? If your limit will be equal to your functional value at A, then we will say your function is continuous at a point A. Okay, how will you see by sequence? Okay, let's see the example. Suppose for x square case, let limit x tends to 1 of x square. What is it? 1 only, 1 square, which is 1. And what is f of 1? Both are equal. It means that this function is continuous at a 1. Right?
Yes, sir.
Okay, so whenever the function is continuous, then only I can, for finding the limit, then only I can find directly putting that value. Suppose you have this function, x raised to the power 5 plus 4x square plus 5x, 5. Okay, and you need to find the limit x tends to what? 1. What it will be? It will be f1 only. Why? Because it is continuous, right?
Yes.
Yes, sir.
Okay, so that kind of thing I can do. But in this case, x square minus 4, x minus 2, the functional value f of 2 does not exist. If the function is not defined at 2, we are not able to talk about it is continuous or not. Because for being continuous, your A has to be inside domain firstly. right? So in this case, the function is not continuous.
But I
Okay,
think your voice is lagging.
my voice is lagging. Okay, just a minute. Let me check my
No,
internet.
sir.
No,
No,
sir.
sir, it's clear.
It's fine, sir.
It's fine.
Yes,
Okay,
sir.
can you please check your internet connection,
Yeah, sure,
or
sir.
you can refresh yourself. Okay. Okay, so in this case, limit exists. Okay, limit exists in this case at 2, which is equals to what? 4, right? But not continuous, because 2 is not inside domain. Got it?
Yes, sir.
Okay. Okay, so I will share you what? Here I have some direct example. Let me see I have or not, which will be helpful for you. Trigonometric.
Sir, can I ask you a doubt?
Yes, you can.
Please tell me if my understanding is correct, sir. So
Yes.
when the sir was telling in the video, he was telling there is a difference between evaluation and substitution.
Yeah,
Evaluating
that
a
I have.
okay.
Yeah, you just tell.
So when in the function definition itself, if they have given a particular value at a point, then we are evaluating. But when we are substituting a particular, say if you're finding trying to find the limit or something like that, then it's substitution. Am I right, sir?
Yeah.
Okay.
But we cannot directly evaluate the limit by substituting method, because I have given the example like this. Here I cannot directly substitute x is equals to 2. It will create some problem. For that, I have to manage this function somehow.
Yes, sir. Yes, sir. That I understood.
Okay.
So in this, we are first we are manipulating and we are making a function.
Then we will substitute.
Okay. Sir.
Okay. For continuous case, we will directly substitute and then got the value. But if function is not continuous, like this case, we are not able to find that kind of thing.
Okay, sir.
Okay, I will give you one more. Okay, so before going this, here are some here are some rules for finding the limit. That is very trivial, so I am not going for that. You can easily see. Okay, you just go through it. This thing is exactly same as sequence for sequence that we have done already. Okay, this sandwich principle I already explained in sequence as well. Okay. Okay, so suppose you have an example. Why I am saying that particular thing? Suppose you have this example x square plus 2 when x is not equal to 2 and 0 when x is equals to 2. Okay. Now, what is the limit x is equals to 2 f of x? What is that? Can someone quickly tell me what is the limit at 2 of f of x?
0.
0.
Why? Does this kind of function continuous at 0?
So it is 4.
It is 4.
How 4?
Why?
6.
6, right?
6,
It will
sorry.
be limit x tends to 2 x square plus 2, that will be equal to 6.
Yes, sir.
Right? But which is not equal to 0. If I will directly put x is equals to 2 here, I will get 0. But that is incorrect, right?
Yes, sir.
Yes.
Right? But here I can put. Because this function not like there is no such issues to substituting direct x is equals to 2 for this case only. Okay, but similarly in this case I have seen if I am here directly substituting the x is equals to 2 value, I am getting some problem because this will become a 0 by 0 kind of thing which is not defined, right? So for that I have to manipulate this function. Somehow I will manipulate this function and then I will substitute the value. Okay, so that is the question.
So for this condition, as you told up, so please go up. As you told, you getting the 0 by 0 form, we can use L-Hospital rule.
But we did not discuss about L-Hospital rule till now.
Yes, sir.
That is why we can, okay? But right now I can't.
Okay, sir.
Okay. Okay, so yes.
Sir, if you don't mind, could we just speed up a bit?
Yeah, okay.
Oh, thank you, sir.
Okay. Now, what is continuity of a function? Here we have learned continuity at a point. Okay, at a point. Now, here I will discuss continuity of function. It means that whether the function will be continuous or not, that we have to know. Okay. So fx is said to be continuous if it will be continuous at for all x belongs to your domain. If it means that if this function is continuous for all that domain value, then we will say this function is continuous. Okay, easy, right? If the function is continuous for all x belongs to D, for all x belongs to your input values, then we will say your function is continuous. Just like fx is equals to x, fx is equal to sine x. These are the example of function. These functions are continuous for all the x belongs to R. Okay, so these functions are continuous on its domain.
So what
Okay.
does it mean that all in all domains it is continuous? We have to check the if in all the inputs they are continuous or not.
Yeah, that we have to check. See, when they will ask for continuity, they will ask continuity at a point only. If the because what are the functions you have till now, that
Yes.
function are automatically continuous, or if they are discontinuous, then they are discontinuous at some point only. Okay.
Okay,
But
okay. Yes,
overall,
sir.
those
Understood.
functions are continuous. Okay.
Yes, sir. Yes,
What
understood.
functions will you studied?
Yes, sir. Yes, yes.
But here
Understood.
that function I have already given like this 1 0. Okay, x belongs to q and x belongs to q complement. See,
Yes, sir.
this function is not continuous at any point.
Yes.
Why? Because limit does not exist at any point.
Yes, sir.
Okay, so that
Yes,
kind of
understood.
thing is happening.
Yes, sir.
Okay, now after that, differentiability. Okay, I am giving you 2 minutes rest. Okay, is it fine for you?
Sir, 5 minutes.
Okay, 5 minutes.
Okay, sir.
Thank you, sir.
Okay, we will start by 9:30. Thank you, Sanj. Thank you. Thank you.
You're welcome, sir.
Sorry. Hello. Your voice is not audible.
So she said, "You're welcome."
Okay. 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 Shall we start now?
Yes, sir.
Yes, sir.
Okay, so after this differentiability, now after this, what we have left? We have left that differentiability of a function concept, then the relation between tangent, then the linear approximation of a function, then what? L'Hospital rule, then integration, definite and indefinite. That's all the thing that we have left till now, right now. Okay. So what you want? You want me to explain in the same way that that I am explaining right now, or you want me to directly explain that definition so that this thing will cover in a very short time?
You explain the way you explained yesterday, day before yesterday, and continuing today, sir. Please.
Okay. 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 So if it is too slow, then please let me know, because I am expecting you guys, each and everyone will explain the understand this concept. That is why I am too slow. Okay.
Okay.
If you will feel like the speed is too slow, then please let me know. Okay.
Sir, please
Okay.
continue.
Okay. Okay. Let's start. Just a minute. Just a minute. Okay. Okay. So differentiability. Okay. Differentiability of a function. So before start differentiability, I will ask some question to you. Okay. So that example you have remember or not, which is covered in the lectures video. Like if I am coming, if my friend is coming, a friend is coming. Okay, my friend is coming from Nagpur or whatever you can say, is coming from Jaipur to Chennai. Okay, he is going from Jaipur to Chennai. Okay, I don't know what is the distance between these two points, but I am expecting that the distance is around 400 kilometers. Okay, so he is covering 400 kilometers in 5 hours. Okay, so if I will ask you what is the speed of my friend, then what it will be?
80.
Or suppose it is sorry. Yeah, I am in Chennai, Vishnu. Suppose it is covering this 400 kilometers in 10 hours. Then 40 kilometers per hours will be the speed, average speed.
Yes, sir.
Right. But the twist is, when my friend was in Nagpur, that was the example, right? When my friend was in Nagpur, uh, like what to say, that traffic police challan, like traffic police fine him for over speeding. But as we know,
Okay, sir.
in any highway, 40 kilometers per hour is a nice speed, right? If its
Yes,
speed
sir.
is 40 kilometers per hour at every point, it means that either the fine was like either my friend is innocent, or he is the traffic police is fine
Not
him
fining
intentionally,
him.
right?
Yes, sir.
Yes.
Yes.
He find him intentionally. The
Yes, sir.
mistake by which is happened by traffic police only. If that 40 km/h speed was correct at every
Yes.
point.
Yes.
But is that true in general?
No, sir.
If
No,
I am
sir.
covering some distance at some particular point, that means at each and every point my speed was same.
No, sir.
No, right? No, right? At some point I was riding at 30 km/h. At some point I will become a Dhoom 3, like Hrithik Roshan or whatever you say, Dhoom 2 Hrithik Roshan, and I will set my Hayabusa and I will go by 120 km/h. That can happen, right?
Yes.
At each and every point my speed is changing.
Yes.
So basically what happened here, the average speed is different, is totally different to my instant speed. Right? What is my instantaneous speed? It is totally different to the average speed.
Yes,
It
sir.
means the
Yes.
speed at the point is totally different to the average speed. It means that I cannot calculate directly by this by this formula, distance by time, or I cannot calculate the speed by this like average speed parameter. I cannot calculate, right?
Right.
Yes, sir.
So for this, the concept is like the concept, the differentiability, the instantaneous change is coming into the picture. So what is instantaneous change or what is differentiability actually? So this difference, suppose this is your function. Okay, I want to know the change at this point P. At this point P, what kind of change I want to know? I want to know the instant change. How the function is instantaneous changing. Like in the just 1 second, how this function is behaving. In the one particular point, how this function is behaving. It means that if this point is A, if I will move this way in just a bit, then how my function will behave. Okay, this thing I want to know. So for that suppose for that suppose this is your point A and I am moving here and I am moving A plus H. Okay, this is just a difference. Like A is my original point and this is what? This is just a change that I have given. I can change by this direction or this direction, whatever it is. But I am changing my function. Okay, a bit. I am changing in my input. So here I am getting this FA. So according to that, I will get the different value FA plus H, right? Right?
Yes, sir.
Right? So what I did here, I did a small change in my input. That change is given by this H. Okay, and I am looking about what change is happen in my output. Okay, what I am saying. Okay, so what is change? I want to say change in output value with respect to it means I am changing in my input value, and with respect to that change, what is the change is given happen in output value. So I need this, right? Value, right? With respect to the change in input value, what is the change in output value, right? I need that kind of rate of change. So change in output value is what? F of A plus H minus F of A, and change in input value is what? A plus H minus A. So this will be equal to what? F of A plus H minus F of A and divided by H. Understood up to this? This is what? This is my rate of change. Okay. Please tell me if you have any doubt up to this.
No, sir.
No, sir.
Right? This is what? This is my rate of change. Okay. Now, what I need instant change. Instant change, what is it means? It means that if I am changing a bit, like in a small pace, small, it means that I am taking this edge as close to zero. It means that I am taking this edge small and small and small and small. Getting my point? Okay. So if this thing is exist, if this change is exist, then we will say our function f is differentiable at a. Got it? If the instantaneous changes exist at a point, then we will say exist at a point. It means that that change is finite. It does not mean that if I am changing my function, and it is like if this is the function, okay, like that. Here this function directly jump to here, so I cannot directly see the jump, right? I cannot see what is the change. Existence of this limit, it means for this LHL and RHL will be exist. But here, if this is the change of the function, here this thing is not happening at this point. You're getting
Yes,
my
sir.
point?
Yes, sir.
Right? It means that it is not differentiable at A. So a function f is said to be differentiable at A if limit h tends to A, f of A plus h minus f of A divided by h exist. Easy? Easy, right?
Yes. Yes.
Yes, sir.
Right?
Sir,
Yes.
in this case, we have to also define from left and right, right? Like
Yeah, in this case, we have to define left and right. But I have already explained you what is left hand limit for limit case. Here you can easily see what is left hand limit, what is right hand limit, right? So in this
Sir.
case, this thing is known as, if you will calculate the left hand limit, in this case, this will define as left hand derivative. Okay, this will be known as left hand derivative because I am doing this thing on differentiation thing. So the terminology is changing, and we will know the left hand derivative and the right hand derivative. Here this is
Sir.
0. Okay. Yes.
Sir, take an
Yes.
example on this formula.
Yeah, I will give you the example. Don't worry about it. Okay. Now, suppose you have fx is equals to x. Don't worry, I will give you the example.
Sir, please explain the difference between the differentiability and continuity. So as here is also it is a limit which is we are measuring.
I will explain. I will explain. Okay.
Okay, sir. Okay.
Okay. Just a minute. Just take a minute. Okay.
Okay, sir.
What is the basic difference? Okay.
Yes.
So suppose you have fx is equal to x, and suppose x is equals to 1, you need to check if the function is differentiable or not. So what you need? So what is this is y is equals to x line, right? I need to take the change, see what is the instant change, right? So how will you check? Limit h tends to 0, f of x plus h or a plus h. I have to see a plus h minus f of a divided by h. So what is the value of a here? F of 1 plus h minus f of 1 divided by h, right? Limit h tends to 0, What is the value of f of 1 plus h? Your f of x is what? X. So f of 1 plus h is 1 plus h only, minus f of 1 is 1 only. This will be cancelled out. What you will get? Limit h tends to 0, h by h. Now, this will be cancelled out. Why? Because it is going towards 0, but it is not 0 exactly. Right?
Yes, sir.
This is going towards 0, but it is not 0 exactly. So I can cancel out. So what you will get? Limit h tends to 0, 1. This will be equal to 1. So what is your so you are getting a finite value. It means that this limit is exist, right?
Yes, sir.
Right? This limit is exist. It means that the function is differentiable at 0. And what is the derivative at 0? It will become 1.
So this is like taking limit to the right hand side, right? Like the way you did it.
See, here I did not mention this h is moving towards 0 in the right direction or left direction. Here I am just using the concept of limit. You already know what is the concept of limit, the left hand way, the right hand way, right? So here if you have to calculate, but in this case I can directly calculate because I am getting 1 only. So I can directly put h is equals to 0 here. In this case, here I firstly I have to calculate. This is just like the form of x square minus 4 by x minus 2. Here I cannot put, but after cancelling, I can directly put x is equals to 2 here. You are getting my point. So here no need to calculate that left hand limit or right hand limit. I am directly able to calculate. You are getting? Sir, if it is correct, then its vice versa is also correct or not? Okay, can you just tell me what will be the contrapositive, what is the what will be the contrapositive statement? Can you please tell me?
Sir, x cube root of x, it is continuous but not differentiable.
1 by 3. This na? Yeah, not differentiable. That we will see. Okay, let's take this example. Okay, at 0. We need to check this. It means that we need to check this limit. H goes to 0. F of 0 plus h minus f of 0 divided by h. Means that what we need to check? We need to check this. F of h minus f of 0 divided by h. It means that what we need to check? We need to check this. H raised to the power 1 by cube. What is f0? F0 is 0 only. This means that what we need to check? 1 by 3 minus 1. So what it will be? Limit h tends to 0, h raised to the power minus 2 by 3. It is what? Limit h tends to 0, 1 upon h 2 by 3. Does not exist? Because whenever h goes to 0 here, this whole term will go to infinity. Right? Right?
Yes, sir.
So in this case, we will say, what we will say? We will say f is not differentiable at 0. Got it? One more example that we will take. Fx is equals to mod x. How it is defined? X when x is greater than or equal to 0 minus x when x is less than 0. At 0, we need to check the limit is exist or not. In this case, we cannot directly calculate. We have to calculate left hand side and right hand side both, right? Now, I need to calculate this limit. Limit h tends to 0. Can I directly put mod h minus 0 divided by h, or I need to write this limit h tends to 0,
No, sir, it's
f
fine.
of 0 plus h minus h0. Let me write. Okay, this will what? Limit h tends to 0 mod h by h. Now, when I will go by right side, it means that limit h tends to 0 plus mod h by h. What you will get? You will get positive value, right? Here h will go greater than 0. So it means that you will get h by h. It will be equal to 1 only.
Yes, sir.
Right? Now, whenever I will go towards left side towards 0 in by left side, what you will get? Limit h
Minus
tends
1.
to 0 minus h by h, which is equal to -1. Both are not equal to each other. In this case, limit does not exist. It means that this limit not exist. In this case, this limit does not exist. It means that f is not differentiable. You're getting my point?
Yes, sir.
Yes.
Now, this will be more clear, right?
Yes, sir.
Okay. Now, the derivative function. Okay. After that, the derivative. This is just a definition. Derivative function.
So can you please explain again why we are getting limit h tends to 0 only? Means h going to 0 and then f of a plus h we are getting the formula.
Sorry. Can you please explain?
So for discussing any differentiability, so why we are getting on for h limit h tends to 0 means
Why
h
why you are taking h tends to 0? Because
yes
we
sir,
need to
yes.
check. Where is the definition? Okay, here. We need to check. We need to. Can you please mute yourself?
Okay, sir.
Because we need to check the instant change. It means that the change whatever I am doing here, it will be smaller and small whatever I can take. So it means that the changes I am taking very small. Very small means it means the changes is going towards 0.
Okay, sir, understood. Okay.
Okay, the change is not so big. It is too small. Okay,
Okay, sir.
because I need the instant change. That is why. Okay, nice question.
Yes, understood.
So the derivative function. Okay, so this is just a definition for a function fx. Its derivative function denoted by f prime x or df upon dx and defined as denoted by this and defined as this is just a definition. Okay, nothing is there. Limit h tends to 0, f of x plus h minus f of x divided by h. Okay.
So,
Yes.
so there is one more, like for negative, I'm just asking, like f a minus h minus like that way also, right?
Yeah, that way also. For that, the change is going towards like here they will specify that thing. But as I have seen your that PDF kind of thing, that lecture notes kind of thing, there they did not mention left hand derivative and right hand derivative. That is why I did not mention that thing.
Okay. So,
So
but
if
like
you want, I can explain those things as well.
it gives the same result though, right? Like
Yeah,
this
it will give the same result. It will give
Yeah.
the same result.
Okay, sir.
Okay, nothing is there. So basically, what is that? What is that actually? Let me explain here. What is that? In this case, the error is going towards 0, right? So in this case, I will take the error going towards firstly the left side, and the second case, I will take the error as right side. Okay, so if I will take this h as positive, always positive, then whenever this h is go towards 0 by the left side, it means I have to take h as minus h, right? Not get. This is a, suppose. Okay. Now I need to see the change by this direction. It means that I have to minus some positive value by this a, right? In this a,
Yes, sir.
right? So in this case, what I will say? I will say I am taking this. This is the change by this where h is positive. So in this case, what I will see? I will say a minus h minus fa divided by a minus h minus a. Right?
Yes.
So in this case, what you will see? You will see a fa minus fa minus h. This will be cancelled out divided by h. I have taken this minus above. Okay. Right? So this is known as left-hand derivative. Okay. Similarly, right-hand side, if I will go here, h is always positive. But what I here that I have explained here, h can be negative, can be positive. Okay. Because I am taking both things simultaneously. But here h is always positive. You're getting? You're getting or not? Please let me
Yes,
know.
sir, yes. Got it.
Yes, sir.
Right. So what will be your right hand derivative? So for right hand case, I am moving towards this. It means that the changes of a is a plus h. So what it will be? It will be f of a plus h minus f of a divided by a plus h minus a limit h going to 0. So this will be cancelled out. So this will become limit h tends to 0 f of a plus h minus f of a divided by h. So this is your right hand derivative. So when we will say the function is differentiable, when the left hand derivative will be equal to the right hand derivative. This is the another way that you have learned in your class 12th. Got it? Hello?
Sir,
Understood? Yes?
sir, can you
Yes, sir.
explain that linear approximation topic also?
Yeah, I will explain those. I will take those topic as well. I have already told you, I will take that tangent version, that linear approximation version. Then I will move towards L hospital. Then I will go for what that integration part.
Okay, sir. Thank you, sir.
So understood up to this?
Yes, sir.
Okay. Now one statement is coming. Okay. One theorem is here. The theorem is saying if f is differentiable at x is equals to a, then f is continuous at x is equals to a. But converse is not true in general. Not true. Okay. So why so? See. This function is differentiable at a, it means x tends to, limit h tends to 0, f of a plus h minus f of a divided by h will equal to some L. Right? This limit will exist if it is differentiable. Right? Please answer.
Yes, sir. Yes, sir.
Right? Now, if see, since h is not equal to 0 exactly, I can multiply both sides by h and take this limit.
Yes, sir.
right? So let this will be same as limit h tends to 0 h into L, right?
Yes, sir.
Because h is not equal to 0. If h is equal to 0, I cannot do this thing. But here I can do.
Yes, sir.
Now this will be cancel out because h is not equal to 0. So what you will get? You will get limit h tends to 0 f of a plus h minus f of a is equals to, this thing will become 0 because h is going towards 0 and L is your constant value. So this thing will become 0. Right?
Yes, sir.
Now, here what you will get? You will get limit h tends to 0. Here, there is no role of this, right? Because this is constant value. Here a is constant. And if you will put a in input, you will get a constant value. So this thing can be explained. So you will get f of a plus h equal to f of a.
Yes, sir.
So this is what? This is your limit. Right? Limit at a. Right?
Yeah, so limit at a.
How it is? See, this is your a. You are moving towards a by this direction. It means that you are taking this and you are moving h going to 0. This is what? If h is positive, this is what? This all the values should lie, it should be less than a, right? If a is
Yes, sir.
positive,
Yes, sir.
it is less than a. If h going towards 0, it means that this a minus h will go towards a, right?
Yes, sir.
It means that this is what? This is the x going towards a minus only.
Oh, okay, sir. Understood. Understood. Yes, sir.
Right? Now,
Yes, sir.
for the left hand case, this is now. For the right hand case, you will take h. Here, h is negative or positive, we don't know.
Yes, sir.
Right?
Yes, sir.
Everyone is
Understood.
getting the point.
Yes, sir.
Okay?
Yes, sir.
Okay, so for this case, f is continuous at a. Get it?
Yes, sir. Sir,
Now,
please, at the second step, what you are doing, limit h tends to 0, h into L.
just a minute. My internet connection is unstable. My voice is audible to all, right?
Yes.
Okay.
Yes,
So
sir.
what did you say?
Sir,
Can you
at the
please repeat again?
second step at the right, at the second step,
Here.
in the right, yes, sir. Right hand side.
Here, what? See, just look at here. H is not equal to 0.
Yes, sir.
So I can multiply this h by both sides with limit, because h is not equal to 0. H is moving towards 0, but h is exactly not equal to 0. So I can go by this way, or you can say you can take this limit from here to here,
Oh, okay. Yes, sir. Then, okay. Yes.
right?
Yes, sir.
Okay. So if you will take this mod x, this is not differentiable at 0, we know now. We have already seen here this case. This mod x is not differentiable at 0. That I have already seen.
Yes, sir.
Yes.
Right? Now, your fx is equals to mod x. How it's look like? X minus x when x is greater than or equal to 0, x is less than 0. What will be its left hand limit? 0 only. How its graph? This, right? When your x going towards 0, the fx value going towards 0 only in the case of left hand side, right?
Yes, sir.
So left
Yes.
hand limit will be 0. What will be your RHL? If you will go by this direction, your right hand value will go towards 0 only. So it will be 0 only. Okay.
Yes.
What is your functional value? Okay, so both are equal. It means that limit exists.
Yes.
Right? And it is what? 0. And what is your f of 0? Put 0 here, you will get 0. It means that limit exists and equal to f of 0. Right?
Yes,
It
sir.
means that this is continuous at 0. But see, this is not differentiable at 0. Means that every differentiable function is a continuous function, but converse is not true in general. Get it? You got the difference between continuity and differentiability,
Yes, sir. Understood.
right?
Yes, sir.
Okay. Okay. Then what? Okay.
Sir, can you explain
Yes.
this again? Continuation and difference.
Okay. So I am saying here my theorem is saying every f is if f is differentiable at x is equals to a, then
Yeah.
f is continuous at x is equals to a. So that thing I have
Okay.
already proved here. I have already proved. Okay.
Yeah.
So here from here I got if f is differentiable, then f is continuous. But again, the further statement is saying, but converse is not true in general. It means that every continuous function is a differentiable function or not. We cannot say anything about it. It can be differentiable. It cannot be differentiable. Okay. By
Right.
this example, I am showing fx is equals to mod x. This is not differentiable at 0. That I have already proved here. Here you can see the both limit not equal to each other. It means that the f is not differentiable at x is equals to 0. I have taken this example. But as I have seen, the left hand limit is also 0 for the continuity. For right hand limit is also 0. It means that at 0 limit exists and it is equal to f of 0. It means that continuous at 0. So this function is continuous at 0 but not differentiable at 0. It means that continuity does not imply differentiability. Get it?
Yes,
Yeah.
sir. Sir,
Yes.
sir, if function is continuous, then
Mhm.
limit must be exist.
Yeah, limit must be exit.
Okay.
Okay, function is continuous. It means that limit exists and then limit is equal to functional value at that point.
Okay.
Okay, the limit is nothing but the limit will be functional value at that point. Got it?
Yes, sir. I got it.
Okay. Okay.
Sir, I'm getting confused. Can you please explain the meaning of differentiability? Means, as continuity explains that if a graph is continuous, then at any point, then the graph is not breaking at that point and go through that point. Uh, then what is the meaning of differentiability like that?
That means
Means
the
what
differentiability at
signifies
a
this?
point, it means that it will instantly change. The instant changes exist or not. Okay.
Okay.
Like in the both direction, that change, if I am talking about the change, the instant change, the change is exist or not. The instant change. In the case of speed, you have seen whenever you will ride a bike, you can see the instant speed, right, in your speedometer.
Yes, sir.
Right now your bike is riding, so that kind of instant change. So in every second your speed is changing, right? The rate of
Yes.
change, how fast your function is moving forward.
Oh, okay, sir. Understood.
Okay,
Yes, sir.
how fast that thing is accelerating or deaccelerating, whatever you can think.
Yes, sir. Yes, sir. Understood.
Okay. Okay,
Yes.
the speed of change, how fast is fluctuating kind of thing.
Yes, sir.
Okay, with respect to time we will see on that thing. Now after that, indeterminate form of limit. Okay, here the concept of differentiability is and now here L hospital rule and indeterminate form. Basically I have to explain this thing before the continuity and differentiability, but since I need to explain that L'Hospital rule simultaneously, that is why I am explaining this thing here. Okay. So what do you mean by indeterminate form? Can someone tell me? What do you understand by indeterminate form?
It's an infinity by infinity or 0 by 0.
Is 0 by 0, infinity by infinity, that kind of. Okay. So
Sir,
everyone knows that kind of form,
sir,
or
can
you
it
can
be
say,
like minus infinity over like this sign can be different, right?
let's see. Firstly, you need to understand why we will call it in the indeterminate form. Is someone have any idea about it, why we will call this is an indeterminate form?
Because it's undefined.
Is this so? If I will talk this same example, x square minus 4. This is 4, right? 4 is defined. But still, this is an indeterminate form, 0 by 0. Anyone? Why it is called indeterminate form? Okay, let's talk by sequences A and B n. Okay, let's talk it by sequences. Or you can say function, okay, function fx by gx. These two function, okay. All the nice thing you can expect that gx is not equal to 0 at any point, that kind of thing, whatever you have required, you can take. Okay. Now this function is how is this function? This function is like this function as x going towards a, your functional value, suppose this is your a, for fx I am talking about. Okay. So whenever you are approaching this function, by any direction, okay, I'm not talking about any specific direction. Either this will go by this way, this go by this way, or this thing also you can take. So what I am trying to say actually, okay, let's talk about this 0 by 0 form. So I am saying limit x tends to a, f of x is equals to 0, which is same as limit x tends to a gx. Okay, both function is going towards 0 as x going to 0. Okay, this is my condition, initial condition. I am explaining that why we will call it indeterminate form. We don't have anything about this function. Okay.
Okay.
Okay. Now suppose your function is moving like this. 1 by 10 and 1 by 10 raised to the power 1, 1 by 10 raised to the power 2, like this. This is also going towards 0, right?
Yes.
Right. Now, your gx is also going to 0. It means that if I will talk about 1 by gx, it is going towards infinity, right? Right?
Yes, sir.
If gx is going towards zeros, it means that this is going towards infinity. If I will give its name hx. Now, I have to discuss about this fx into hx now, where your fx is going towards 0 and hx is going towards infinity. Okay.
Okay.
Okay. So before discussing it, let me ask you one simple question. What if your f into g, in this case, your g is moving towards, suppose some positive value 2, and your f is going to 0, then the multiplication of both function will go to what? Where this multiplication will go? If this is going towards 0, this is going towards 2, then where this multiplication will go?
0.
0 only, right? Okay. Now, another case. If this is going towards 2, this is going towards infinity, where this function will go?
Infinity.
Infinity. Okay. If both function, this is going to 0, this is also going to 0, where this will go? 0 only.
0. Yeah.
If f and g both going towards infinity, means that where this will go?
Infinity.
Infinity only. It means that if I am seeing this 0.0 form, 0 some constant form, 0 okay, 0.0, 0 constant, infinity dot 0 or infinity dot infinity. These all things can be observed. We can directly observe and we can directly say what will be the limit. We can directly we can directly think about the limit, right?
Yes.
In all of this case. But what about this case? When one function is going towards 0, one function is going towards infinity. What about this case? We are not directly, we cannot say anything. Why we cannot say directly anything? Because suppose your function is moving towards like this manner, 10 raised to the power minus n, or suppose it is moving 10 raised to the power 1, 10 raised to the power 2, and that person is going n square way. Like firstly it is 10, then it will become what? 10 raised to the power 4, which is 10,000. Okay, then it become 10 raised to the power 9. Okay, 9 zeros. So this thing is going towards infinity, and this thing is going towards what? 0.
Yes.
Right? This is your h. Understood up to this? Here this thing is going towards 0, this thing is going infinity. So you are taking this form only, right? 0 dot infinity form, or 0 by 0 form, you can say. Right? Right? Now, observe that whenever I will multiply these two functions, where this function will go? First function this, and here 10, this is equal to 1. For other case, this is 10 square, here 10 4. This will equal to what? 10 square. Next thing, 10 cube, 10 9. This will equal to 10 6, 10 raised to the power 6. 10 4, 10 16, 10 12. Where this is going? Where the multiplication is going?
Infinity. Right.
Infinity, right?
Yes.
Right? Infinity.
Yes.
In this example, this is going towards infinity.
Yes.
Now, again, in the another example, 1 by 10 is here. Suppose 1 by this is going to f is going like this: 1 by 10, 1 by 10 square, 1 by 10 cube, like this. And your g is going like this: 10, 10 square, 10 cube, like this. So whenever you will multiply f into g, where it will go? 1 by 10 into 10 is equals to 1. 1 by 10 square into 10 square is equals to what? 1. It means that you will get always 1.
Yes.
So in this case, where it is going?
Towards
1 only.
Yeah.
But the form is also 0 by 0 or 0 by infinity form. This is h, okay? This is h. Right? The form is same. But in the both case, in this case, this is going towards infinity. In this case, this is going towards 1. You are getting my point?
How it is 0 by 0?
See, I have explained you now. Here, where is it? In this case, if fx is going towards 0 and gx is also going towards 0, it means that 1 by gx is going towards infinity.
Yeah, okay.
Okay, so take hx is equals to 1 by gx. So this hx is going towards infinity. It means that this is nothing but 0 dot infinity form, or you can say 0 by 0 form.
Okay.
Okay. Now, here what I have seen, what is the observation? Observation is that in some cases, the multiplication is going towards infinity. In some cases, this is going towards some finite value. It means that this is exists. And if I will give you a different example where this function will go to 0, like if your function is moved like this, 10, f is going toward like this, 10 square, 10 cubes, and your g is moving like this, 1 by 10, then 1 by 10 raised to the power 4, 1 by 10 raised to the power 9, 1 by 10 raised to the power 16. Then if whenever, sorry, this is h. Whenever you will multiply this, what you will go? You get 1. Then here 10 square. Then here 10, 6. Then here 10, 12. You are getting my point? This is going towards 0 now.
Yeah.
Right? So what is the observation in this form or this form? We cannot observe directly, right?
Yes.
Just looking of the function, we cannot say anything about that, whether this whole multiplication will converge. Right?
Right.
Right? But in this case, what we have seen, we was able to expect the value whether this function will go.
Yes.
So this form is known as determinate form. Okay, determinate form, where we can directly observe the function and we can directly say where the function will go. And in this case, this form is known as indeterminate form. It does not mean that indeterminate, we cannot find the limit of indeterminate form. We can find, but in this case, we cannot directly observe then we cannot directly say whether the function limit what will be the limit. That is why it is called indeterminate form. Okay.
Okay.
And understood the point why we will say this is indeterminate form? Getting the idea?
Yes, sir.
Yes.
Okay. Okay. So in this case, in this indeterminate form case, your L'Hospital rule will work. Okay. So what is L'Hospital rule is saying? If I want to find the limit of indeterminate case, so here L'Hospital rule will work, and it is saying in the cases of indeterminate form, suppose the following thing is, suppose the following condition holds true. Okay, the first condition is if your function, if your f prime x and g prime x exist, it means that f and g both are differentiable function. See, whenever you will apply L'Hospital rule, make sure that the numerator function and the denominator function both are differentiable. Okay. Another thing is g dash x is equals to 0, is not equal to 0. Sorry, it's not equal to 0 for all x. You can accept some point, say x is equals to 3. If a function is not differentiable at one point, doesn't matter. Okay, we will not worried about it, because one point will not affect our answer. Here you can say except x is equals to c. And limit x tends to a, f prime x divided by g prime x is equals to L. Then L Hospital is saying, then limit h tends to a is a, sorry, x tends to a, f of x divided by g of x is nothing but this L only. This is what limit h x tends to a, f prime x divided by g. You are getting my point? Just differentiate the numerator function and the denominator function and find the limit. You will get your answer. Got it? For example, take same example. X square minus 4 divided by x minus 2. This is also 0 by 0 form. Right? Limit x tends to 2. Right? Now, differentiate the numerator function. What you will get? You will get 2x divided by 1.
Yes, sir.
I will share the formulas of differentiation, right? Okay. So this will be 2 only. 4 only. 2 into 2, which is equal to 4. Right? Sir, could you please explain what does except C mean? Okay. I will explain. See, except C means you can exclude some point where function is not differentiable. If suppose domain D consists a point C where function is not differentiable, no need to worry about it if at some point function is not differentiable. Okay, then like this is more general case. More general case, it means if a function, see, if you have D as interval I, say A, B, and here 2 to 3 points are like where function is not differentiable, and you have to calculate limit at A, sorry, at some point, say what, x naught. Okay, here some points like C is not differentiable, at function not differentiable, both function, but at x naught you need to calculate. So this is your x naught and this is your A, this is your B, right? So here suppose this is your C where function is not differentiable. So you can make a small interval like this where function is smooth or function is differentiable or continuously differentiable, right? You can make always, because there will be infinitely many elements between x naught and C. So you can always be able to make this kind of interval. So you can look this by this interval, because you need to check in the neighborhood, in the aas pados of this x naught only, right? We don't need to worried about whole the interval. We need to worried about in the neighborhood of this x naught only.
Sir,
Yes, Shivam.
sir, if we
Yes,
like,
Sinu?
if we end up using like L hospital rule, but it was not needed, what will happen?
Sorry.
Like, let's say we use the like we differentiate the numerator and denominator.
Yeah.
But it was not needed. Like, it could have been
In
solved.
this case, in this case.
Yeah, yes, sir. Yes, sir.
Okay. So it does not matter. You can use also, like if whenever you are getting 0 by 0 form, infinity by infinity form, or infinity by minus infinity, that kind of thing, you can directly use L hospital, or you can use whatever you want. Like here you can manipulate that x plus 2, x minus 2, then you can cancel out x minus 2 and then you can calculate. That thing you can do. But make sure that when
we don't have to worry about
yes,
the algebra part, right? So you're saying.
yeah, you don't have to worry about algebra part. But make sure that whenever you will use L hospital, this condition should hold. Okay. If your f prime x and g prime s is the differentiable at that point, okay, this is not a 0 in the ask pados of that point, not. Okay. So Shivam, did you understood this why we are accept? What is the mean of this accept C? Hello, am I audible?
Yes.
Sir, you are audible.
Yes. Yes. Okay. Understood. So if there is some point where function is not differentiable, we can make a small interval and we can exclude that point. That is why we are saying. Okay. Sorry, your voice is breaking in between. Now it's clear.
Yes, sir. It's clear now. Before it was breaking.
Okay. Now it's clear, right? Okay.
Yes.
Okay. One more example I will take. Ln 1 plus x divided by x at limit x to 0. Can someone quickly use L'Hospital rule? Here, this is as x goes to 0, this is going to 0. As x goes to 0, this is going to 0. 0 by 0 form. Can someone quickly
1.
solve this for me? What it will be? 1, right?
1 by x.
1 by 1 plus x.
Yes, sir. 1 by 1 plus x. 1.
When x goes to 0, this will go to 1.
Yes, sir.
Easy. So L'Hospital is easy, right? One more example I will give you. X square minus 5x plus 6 divided by x minus 2 as limit x going to 2. You cannot directly see, check, directly use L'Hospital. Firstly, check it is a 0 by 0 form or not. This is right because 2 is also a root of this. If you will directly put 2 here, this will become 0 and this will also become 0. Right? So you can directly use L'Hospital here. So what you will get? Differentiate numerator. Now, when you will put 2 here, you will get what? 4 minus
minus
5,
1.
which is equal to minus 1, right?
Yes, sir.
Okay. Okay. So L'Hospital is end. Now tangent line and then linear approximation. Okay. So before starting this kind of thing, let me give you some. Okay, I will give you in the end of the class. I have some formulas for differentiation and integration. Sir, from your side, there is a network issue. Okay, let me check. Actually, I am using IITM Wi-Fi right now. So maybe there is some problem on that. Let me refresh it.
Sir, you are inside the campus.
Yeah, I am in campus only.
Not
Now
much.
it's fine. Now it's fine.
Yeah, it's fine.
Pratham?
Yes, sir.
Yeah, in between few seconds, sometimes there is some voice lagging. That's it.
Yeah. It's okay. I cannot do anything about it because this is not my network. I am using
That's not a
IITM
problem.
network right now. Okay. So whenever the lagging is there, just let me know. I will refresh that thing. Okay. Okay. Then tangent line. Okay. So everyone, I already explained you what is tangent. What is tangent line? Okay. Can you wait for 2 minutes? I
Yes, sir.
have
Yes.
to inform something to someone.
Yes,
Okay.
sir.
Sure.
I have some important form. Just wait for. Hello. Actually, my friend is coming to their native. So that's why I have to went. That's why I went there. Am I audible?
Yes.
Yes, sir.
Okay.
Yes,
Okay.
sir.
So
You are
let's.
on.
Okay. So basically, what was the tangent line that I have already explained you? So I am writing, just recalling that definition. A tangent line is nothing but tangent line to fx at A is a line which represent the instantaneous direction, which instantaneous direction. So what does it mean? I will explain you, okay? In which function is moving. The graph, this one, gamma f, moves to this A, f of A. And what was yesterday's definition? Yesterday's definition was the tangent. Someone was mentioned that definition, that instantaneous direction one, right? And I told them I will explain it whenever I will start that differentiability kind of thing. Okay. So the tangent to fx at A, we can think like that of nothing but at A is a line which just touch our graph, which just touch gamma f at A f of A. So what does it means? So basically, if this is your graph and you need to calculate you need to find the tangent line at this point. So what we need to check? We need to check that line where at this point where function is just, this line is just touching the graph, right? That was I have explained yesterday, right? Where this line is touching our function. If a line is just touching at that point, that line will become your tangent line. That was I have explained yesterday. Now, how did we got this line? Now, I have defined this line, this line, this line, and I was moving forward like this direction. And once I reached at this point, I got a line at this point where this line is touch this function at here, at this point. And this line will become tangent line, right?
Yes.
That was the yesterday. Okay. So the first definition is saying a tangent line to F at A is nothing but it is a line which represent the instantaneous direction. What do you mean by instantaneous direction? It means that suppose this is your function and at this point you need to find the line and you are moving this A towards this way. Okay, you are moving like this. You are moving like this. So your function is moving like this. Suppose this is line. So your function is moving like this, and in this case like this, right? What is the direction? The direction of like this, right?
Right.
This kind of direction your function, if you are moving like this. So at this point, there will be some direction function, right?
Yes.
So this instantaneous direction function, if you will circulate like this will become that line only. If you will move this vector like this will become that line vector.
Yes.
Yes, sir.
You are getting my point? So this is nothing but this is the instant direction of the function.
Yes.
And this is also same as tangent.
Yes.
This is not so accurate, but I am just giving you the motivation why we are saying that, why we are using that definition. Okay. I am not saying this is totally accurate, but I am just saying why we are using that definition also for tangent line. Okay. You're getting my point? I am just trying to correlating those two definition only. You're getting my point?
Yes,
So
sir.
at this point, this is what? This is just an instant direction. And if I will try to see like this, I will see this is nothing but this is just a tangent line. You're getting why I am saying this instantaneous direction. So this is the actual definition of tangent line. Okay. This is the actual definition of tangent line. Okay. This is just you can think like this. You can think like that, but this is not the actual definition. This is the actual definition. Instantaneous direction of a curve at that point. Getting my point?
Sir.
Okay. For yes.
Sir, what that symbol represent after the graph L shape?
This is.
Yes, sir. Yes, sir.
This is gamma. This is known as gamma of f. It means that you are saying about graph of f. That I have already defined in yesterday's class.
Okay, sir.
Did you went through it?
Yes, sir. I watched yesterday class, but I don't find the gamma part.
Okay. This is known as gamma, but this is nothing but this is represent a graph because for some function we have to represent that graph only, na? So I use that symbol.
Okay, sir.
Okay.
Okay, sir.
Now you understood the concept of tangent. Now, how this tangent line is related with the derivative. Okay. So next thing is tangent and derivative. So how this thing is related to each other. Okay. Suppose this is your function. Now here you need to calculate this tangent line at A. Now I am saying I already told you we need this is your function, you need to calculate the tangent line. What you will do, you just calculate like this. I am saying this is your point AFA. Now what you will do, you will take now clear my voice? My voice is clear now?
Yes, sir.
Hello. Continuously popping. Your internet connection is weak. Your internet connection is weak. That is why. If there will be some lag, then please let me know. Okay, I will explain further. So
Okay, sir.
let this change. FA plus H by this direction or any direction. Okay. So what I need to go by this direction? Okay. Let's make a line. This line. So you have 2 points. You have 2 points.
Sir, your voice is breaking.
A plus F, A plus H, and what is another point is your hello. Now it's fine.
Yes, sir. Now it is fine.
Fine, sir.
Hello. Now it is fine. Okay. So what I am changing this function by A plus H. So from this I got two distinct point, right? Right?
Yes, sir.
Yes, sir.
Hello. I got two distinct point. Now I have two distinct points, so I can make a line which is passing through by these 2 points, this line.
Yes, sir.
This line, right? This line. Here 1 point, here 1 point, right?
Yes, sir.
Now, if I will take this edge goes to 0, it means that this line will approximate to tangent line. How it is approximate? Suppose this is your curve, this is that line. Here you need to check. This is your point where a plus h, f a plus h. Now, if your h will goes to 0, it means that here a and a plus h. Here this a plus h moving towards a means that this point is moving towards a, means that this line goes by this. Then after that you will get your that tangent line, right?
Yes, sir. Now understood. Yes.
Understood. Now, what is the equation of the line moving moving by these 2 points? It will be y minus fa is equals to f a plus h minus fa divided by a plus h minus a into what? A plus h minus a only, right? Right?
Yes, sir.
Okay, just put this a plus h x. So what you will get? You will get y minus a fx minus fa divided by x minus a. Okay. This is the line. See, here x is nothing but x is your a plus h only.
Yes,
right?
sir.
So in this case, as h goes to 0, it means that here x goes to if h goes to 0, it means that h goes towards a. You're getting my point?
Yes, sir.
So you're getting through.
So if you will take as x goes to a, you will get your tangent line. If you will take limit x goes to a, you will get your tangent line, right?
Yes, sir.
This will become your tangent line, because if I will take this h as goes to 0, it means that after some time this line will approximate to your tangent line.
Yes, sir.
Getting? Okay. So this line will become your tangent line. So this is your tangent line. Right? By the definition of tangent. Okay. This is what? This is nothing but your f prime a, na? Or here
Yes,
you
sir.
can see, if limit h tends to go 0, this is what? A to a cancel. This is nothing but this is your f prime a, derivative at a. Right?
Yes, sir.
Right? Into x minus. So y is equals to f prime a into x minus a plus f of a. This is the equation of tangent line if function is differentiable. Got it? So this is
Yes,
the
sir.
relation between tangent line and the derivative function. Got it? Or this thing is known as the linear approximation of a function. Of a
Understood, sir.
easy, na? No
You
rocket science
explained
is
it in a
here.
very easy way, sir. Thank you, sir.
Okay. So this thing is also known as a linear approximation of a function. Got it?
Yes.
So now in this case, whenever they will ask what is the linear approximation, you will talk about this Lx. So your linear approximation of a function will become your f of a x minus a plus f a. This will become your linear approximation. Okay.
Yes, I understood now.
Now I will give you some example. Fx is equals to cos x at a is equals to pi by 3. So what will be its linear approximation, or what will be the tangent line at pi by a? It will be Lx is equals to f prime a. It means f prime pi by 3 into x minus pi by 3 plus f of pi by 3. So why I am saying this is the linear approximation of a function? Because this is nothing but this is the equation of line, right? And here what we are doing actually, what we are doing by this manner. Firstly, I have tried this way. See why I am saying this is linear approximation, because if this is a function in this interval AB, so if you if this is also an linear approximation of a function, right? At this point, suppose C. This is also a linear approximation if I will draw this line at C. But this is very bad approximation, right?
Yes.
Right? If you will move like this is a bit good. This is a bit good. Like this, if I will move, I will take like I will get a very good, very appropriate linear approximation. And if I will see, this is nothing but this is a tangent line only. Right? And as well as this is also linear approximation of a function. So the best linear approximation of a function at a point is nothing but a tangent line at that point of a function. Got it? Why we are saying linear approximation? Because
Yes,
we
sir.
are approximating in a linear form, in a linear way, in a line form at that point. Got it? Now, in this example, what it will be? Okay, so what is f prime x in this case? Can someone tell me what is the differentiation of
Minus sin x.
minus sin x? Okay, so what is at pi by 3? Minus sin pi by 3. What is the value of sin pi by 3?
Root under 3 by 2.
So it will become minus root under 3 by 2.
Oh, yes, sir.
Yeah, it is fine. This is correct. Okay, pi by 3 it means 60 degree. And sin 60 means 3 root 3 pi by 2. Just look at this thing also. Okay, you can easily find in internet what are the values of this different angle. Okay, and what is the value of cos pi by 3? This is nothing but this is your f pi by 3 only. So what is the value of cos pi by 3? It is 1 by 2.
1 by 2, yes, sir.
Okay, so just put the value. What you will get? Minus 3 by 2 x minus pi by 3. See, there will be some question. They will ask you some question like this. Just find the linear approximation of a function. So this will become your linear approximation of a function at pi by 3. Or you can say this is your tangent line at pi by 3. Got it?
Yes, sir.
Yes, sir.
Okay. Okay. Now let's move forward. The further thing is local maxima.
Sir, it will be 1 by 2. You wrote 1 by 3 by mistake.
Okay, sorry. Okay, sir. Okay. So what is local maxima and local minima? Do you have any doubt up to this?
No, sir.
No, sir.
Okay, this class is also going, I think, up to 12. I think because there will be local maxima minima things. After that, integration will start. Okay. After that, only integration will start. And I cannot split this class now. because your exam is too near and there are some clashing kind of thing. Okay.
Yes.
Okay.
Okay, sir.
So if you will be tired, then please let me know. I will somehow I have to make this class no matter how much long it will go. So you can go by YouTube recording as well. I don't want to make this the longer class, but it's not up to me. It's already pre-decided. Okay.
Sir, it's fine, no problem.
No issue, right? So please be patient. Okay, so let's start. So you already know the concept of increasing and decreasing, right?
Yes, sir.
And decreasing. Decreasing on in interval. Interval, you can say. Interval say AB. What does it means? It means that if f is increasing, it means that if you will take two distinct points x1 and x2 like this, you will your fx1 is less than or equal to fx2 only. It means that your function is increasing like this, or you can say like this. This kind of thing is happen, right? So this is known as increasing function at this interval. And similarly, decreasing function, if you take two distinct points like this, so you will get like this. So this thing I have already explained. That is why I am just touching it. Okay. Now after
Yes,
that turning point, also I have explained, I guess. So what is the actual definition of turning point? That I am writing. I did not write the definition of turning point yesterday, right?
No, sir.
So a point, I just explain and then I leave it. So what is the turning point? So at a point X is said to be a turning point. Point of fx if one of the following conditions. If one of the following conditions holds, then we will say this is the turning point. First one is either there is an interval of either there is an interval of this there is an interval of increases in ending. I will explain what is it means at x and an interval of decreases beginning. Okay, what is it means beginning? What is it means actually? The second is also like this, or there is an interval of decreases ending and an interval of increases beginning. What is it means? Both I will let you know. So see, means that if this is an interval A and your function is defined like this. Okay. So yesterday I have already told you this point will become your turning point, right? This point C will
Yes,
become
sir.
your turning point. Now, just observe here. If you will see in this interval, function was increasing up to this, and then suddenly function stop increasing. Then suddenly function stop increasing, and then it started decreasing.
Yes, sir.
Yes, sir.
Right? In this case, function is started increasing, then it stopped at C, and then it started what? Decreasing. So in this point, you can say in this interval, the increasing part is end, and in this way, the decreasing part start.
Yes, sir.
Right? In this interval, the decreasing part start. That thing I have written here. There is an interval of increases and see, this is an interval of increases and the n interval of decreases beginning. But now here the interval of decreasing start. Okay, at this point C, then this C is an turning point. Got it?
Yes, sir.
Okay. Similarly, in the second case, if this thing is happen, A, B, and this is C. So in this direction, you can see the interval of decreases ending here, and then it is started increasing. So the beginning of here in this interval, what is going on here? The increases the function is started increasing, right? And ended what? Decreases. You're getting my point? What I am saying here, in this direction, firstly, how was the behavior of the function? The function was
Decreasing.
decreases, and at some point it stopped and started what? Increasing. So
And
at
that
this
point is
point,
known
if
as
you,
turning point.
yeah, so at this point you can see here the function ends its increasing part and ends its decreasing part and starts its increasing part, right? And
Yes, sir.
this point is known as turning point. Okay. Now,
Yes,
what is
yes,
the
sir.
observation? What is the observation here, sir? This point is also a point of maxima, right? This point is also a point of minima, right? Here function is taking its maximum value, as you can say.
Yes.
Here function is taking its maximum value. So this point will become point of maxima. Here function is
Yes.
taking its minimum value. It means that this point will become function point of minima. So
Yes, sir.
here, this thing, the another definition is coming for turning point. A point is said to be turning point if it is a point of maxima or it is a point of minima, right? You got the idea of turning point,
Yes, sir.
right? Now, any doubts up to
No,
this?
sir.
Okay. Sorry. Sorry. Just a minute. Okay. After that, I will explain what is local minima or why we will call it is local minima, local maximum. Let's start with local maxima or local minima. So I will explain local maxima simultaneously your function. It is dancing like this. So as you can see, maxima and minima you understood, right? Where the function is taking its maximum value. Right?
Yes, sir.
Yeah, this concept you know, where the function is taking its maximum value, it is known as like the that is maximum of a function. Where the function is taking minimum value, that point is a minimum of a function. Now, what is it means locally? It means that if you will see in this interval only, this A and B interval only, this peak, the value of this function at this point will be your maximum value. Means that your FC is greater than or equal to Fx for all x belongs to this AB. Right? Right?
Sir,
Right?
could you repeat it?
What I am saying this FC is the maximum value in this interval. It is a
Yes, sir.
maximum value of a function in this interval because this limit is like this. So all the value of function is less than or equal to this FC, right?
Right.
Yes.
Right? All the values of function in if you are checking in this interval are less than or equal to this FC. It means that this is the greatest value or this is the maximum value in this interval.
Right.
Yes.
Right? Suppose this peak is not like this. This peak is like this much peak. But this value is not a globally, like this is not the entire this thing you cannot say for the entire domain. For entire domain you cannot say like this because here you have some value, suppose f of d, for which your f of d is greater than f of c, right? So you cannot talk about the entire domain, but you can say about this small interval.
Yes, sir. Good.
Right?
Yes.
Got it? So since you are checking in a local region, that is why this thing is known as local maximum, because this is maximum in its region. Right? In the local area, it is maximum. It's just like you have you seen that thing, like in some gaon there, in some villages there will be some dada kind of thing, local dada, then after that underworld kind of thing is happen. Like, so that is its local dada, you can say. But
Yes,
there
sir.
will be some other dada for city level, for state level kind of thing. Okay, so this function is nothing but this function is its local dada. It means that it's the dadagiri will be running on this region.
Yes, sir.
Got it? So that is why it is called as local maxima. Similarly, for local minima, this function will be the lesser value in this region only. But here you can see this is the least value of this entire function on in the domain. Means that, but in the local region there are some small values which are locally maximum and locally minimum. Right?
Yes, sir.
Okay. So same here, local minimum is coming. Now you got got it? What is local maximum, local minimum? So if a value is maximum in a small region, in a small interval, then we will say that value will become your local maximum. Okay. Here
Yes.
we will not talk about the boundary point. Okay. We will not discuss about boundary point. We will discuss about only the between points only. Okay.
Sir, it means A and B are not included in the
Yeah,
domain.
A and B are not included. You can take open interval.
Okay, sir, got it.
Okay. Now, local maximum, local minimum concept clear?
Yes.
Now, what? But now here global thing is coming into the picture. What is global maximum? Similar, you can think for global minima as well. If the dada will become globally like the just like underworld dawn, like
Yes, sir.
this underworld dawn is a papa for each and everyone dawn, right?
Yes, sir.
This will become, this will be a bhai for each and every small dawn. It means that this is the biggest person like this
Yes, sir.
in the entire world. That is why it is known as underworld dawn, right? So this thing, if this thing is happening, like here for this case, fd is greater than or equal to fx for all the value of x belongs to d. D is your domain of f. Are getting my point? If this thing is happening, then D is known as point of global maximum. Get it?
Yes, sir.
Now, okay. Now, how will you get this? How will you find this global maximum? Now, I have some way. I have some way. Some way why this? Why that I can find I can find that global maximum and global minimum. But I know one thing. I know one thing that one of the local minimum or local maximum will become your global maximum if domain is infinite.
Yes.
Right?
Yes.
One of the global minimum or global maximum will become your, sorry, local maximum or local minimum will become your global maximum, or the other case at the boundary point it will become like, if this is like this, okay, this is your a, this is your b. Here f of b, here I am including the boundaries, okay. This is your domain, suppose. When we will check locally, we will exclude the boundary. But when we will check for globally, we have to include the boundary. Okay. So if this is your domain, this closed interval AB. So your for FB, this thing is happen, right?
Yes.
Right. This FD is your global maximum. You're getting my point. But
Yes, sir.
But this FB is not, this B is not a point of local maximum. Are you able to see? Why? Because we have, for checking local maximum, we have to exclude this B.
Yes, sir.
Got it? But it is a point of global maximum. So how will you find that global maximum? Firstly, find all the local max value. Then find the value at boundary point, because this is also important. Boundary point means like this. Then compare. The biggest value, the maximum value, will become our global maxima.
Yes, sir.
Right? Right? Similar for global minima as well. You're getting?
Yes, sir.
Right? If someone has given me a question, let me see. Here is some.
Sir, we
Like
can move
fx.
forward. We've understood it.
Sorry?
Sir, we understood that global maximum and local maximum. We can
Yeah,
move
I am
forward.
giving. Yeah, I am giving you the example. Sir, in a graph, there only one turning point. Can we consider that point as global and local extremum? Yes, we can. If every turning point is an global local extremum. See, global maximum or global extremum will be unique. Okay, there will be only one global maximum or only one global minimum. But every point of global maximum or minimum cannot be a turning point like this. In this example, this is not a turning point, but this is a point of global maximum. You're getting? This B is not a point of, this B is not a turning point. Why so? Because this is not a point of local maximum. I have already told you what is the point of local, what is the local maximum or local minimum, what is the turning point? Either it is a local point of local maxima or it is a point of local minima. But here, this is not a point of local maxima or minima. This is a point of global minima, global maxima, I know, but this is not a point of local maxima. So it cannot be a turning point. Right? Got it, Subham? Shivam? Okay. Okay. So let's move to the derivative test. Okay. Before starting derivative test, you can as easily see in the, like if this is a local maxima, here tangent is 0. Right? Because the instant change will become 0. The direction, the instantaneous direction will be parallel towards x-axis. Then your tan x will become 0.
Yes.
Right? So the slope is 0. It means that f prime x is 0. At what? At turning point. Right? So it means if A is a turning point, this is a small thing. Okay. Then f prime A will become 0. Got it? Now, let's talk about derivative test. Second derivative. Okay, before starting this, one more thing is remaining, critical point. So nothing is there, critical point. A point A is said to be critical point if either f is not differentiable at a point A is said to be, or if it is differentiable, then f prime A is equals to 0. No rocket science here.
Yes.
Right? Okay.
Yes.
So either it is not differentiable at that point, or if it is differentiable, then it is
You are not audible.
Am I audible?
Yeah, now
Yes, you're audible, sir.
Actually, I was disconnected. Okay.
Okay.
I'm not able to share my screen. Just a minute. I think there is some one glitch. Okay, let me message on the group. If you have some doubt, you can ask me now, because my screen is, I'm not able to share my screen.
Sir, you need to ask permission from host.
Yeah, that is why I'm sending a message. Just a minute, okay? I was disconnected and then I'm not able to say. Here, one option is there, whiteboard. I need to sign in. I have dropped a message. I don't know when they will see. Yeah, got it. Got it. Got it. Okay. They seen the message. Just in a few minutes, I have. In few minutes, I
Ask
will be
them
able to
to,
share this.
sir, ask them to
Yeah,
make you host.
yeah, I cannot because IIT Madras BS team is on the host. Okay.
No, sir, you could
Cannot.
told them to make you host also.
Yeah, I already told you that. Please make me co-host.
Okay, sir.
Just within few minutes, I will be able to share my screen.
Yes, sir.
Yeah, then got it. Visible to all?
That's okay,
Hello?
sir.
Yes.
Yeah, visible to all, right? Let's start. So, what is saddle point actually? Let me start the chat box as well. Okay, so what is saddle point? A point is said to be saddle. So basically, the concept of saddle point is like this is defined for multivariate calculus. Okay, this is not for one variable calculus. The for one variable calculus, this point is known as point of inflection. Influation, sorry. But for your course, it will be known as saddle point only if it is okay a critical point. Okay, not on any point, a critical point. A critical point is said to be a saddle point if it is not a point of local maxima or not a point of local minima. Okay. If a critical point is not a point of local maxima or not a point of local minima, then that point will become what? Saddle point. Just like, for example, fx is equals to x cube. In this case, as you can see, this is your graph. Here, if you will see f prime x, you will get 3x square. So x is equals to 0 will become your what? Critical point. But here, this point is not a point of local minima or nor a point of local maxima, right? But still, this point is a point of local. Sorry, this point is a critical point. So that kind of point is known as a saddle point. Okay. Now, just for information, if you have a function fx like this, x square minus 4x plus x cube, and in the question they are asking just find all the critical point. So what you need to see? You need to find all those points where f is not differentiable, and you need to find all those points for which f dash x is equals to 0. It means that you need to find the roots of this equation and you need to find the point where function is not differentiable. Got it? So once you get that critical points, for you need to just check whether this point is local minima or whether this point local maxima or not. So for which the second derivative test will help me. Derivative test for checking local extrema. Okay. So what is it saying? If f is twice differential, what do you mean by twice differential? It means that the function f is differential, the second derivative will exist. Okay. Then if f double prime a is greater than 0, then a will become if a is a critical point. Okay. So for critical point, this test is running. So for critical point, if f double prime a, it means that the second derivative at a is greater than 0, then a will become point of local minima. And the second thing, if f double prime at a is less than 0, then this a will become point of local maximum. And the third thing is equal to 0, then test is failed or inconclusive, you can say. Okay. So this is the way that you can see. So once you got the critical point, you need to check at that point whether this thing is happening or not. If or this thing is happening. If this thing is happening, we cannot say anything about it. Okay. Got it? So this is important. That is why I am explaining this. Okay, so I will give you some exercise. Just check, just take this and find the points of local minima and local maximum. Okay,
Yeah.
this is the exercise for you. Fx is equals to cos x and fx is equals to x cube plus x square minus x plus 5. Now, if you need solution for that, you can message me on my Gmail. I will give you the solution as well. So this is your exercise. You can just go and solve this. So, okay. So up to this week 8 and somehow one part of week 9 is a start. Okay. So here week 9 concept. So here integration is running. Okay. So it's too late. Okay. So I am giving you again 5 minutes break because it will take 1 hour at least. It will take 1 hour. Okay. Sorry for that.
No problem.
Because I don't have any option. That is why I am taking that much longer classes. So I am giving you 5 minute break. Okay. You can just wash your mouth and then come. Otherwise, you will be sleep. But I will try. You will not sleep in the class. Okay. It will take barely 45 minutes to half 1 hour. Okay.
Yes, sir.
It will not so tough. It will be easy. Okay. Just
Okay, sir.
Is it my email okay? There is a chat box in that email. You just go to the chat box and then message me. I will see you. I will see you on message. Some of the student has already contacted me by that mail. Okay. So shall we start? Hello. Hello.
Yeah.
Am I
Yes, sir.
audible? Am I audible? No?
Yes, sir.
Okay. Okay, so integration. Okay, so before starting the integration, I will give you the motivation what we are do. So in this portion, we will do what is Riemann sum. Okay. Then lower sum, then upper sum, then definite integral, and then antiderivative. So because of time constraint, I will not going to write the formal things. I will just go and explain all these things. Okay. So because formal thing you can get by that study material as well.
Okay, sir.
Okay.
Okay. Just go through it because of time constraint. Otherwise, I will. Okay. Then fundamental theorem. Some Newton kind of thing, Newton law, that kind of thing was there. And that's it. After that, we will wind up our class. This all the topic are remains. So basically, this thing we are discussing because of we need to find the area. Okay. So I think this thing I have already explained you in one of the revision session, I guess. So this thing I am also repeating once. Okay. So I will ask you the question. If you need to find the area of this rectangle, how will you find? If this length is your B and this width is your B. If this is A, this is B, how will you find the area of this rectangle?
Multiply A into B.
Okay. So area of this rectangle is what? A into B multiplying by this length and width. I will get that area, right?
Yes, sir.
Right. Okay. What if I have some curve like this? How will I find? I can try to divide it by a rectangle, right? This will become your rectangle. I need this length. Suppose this is A, I need this length. So I can find this length, right?
Yes, sir.
Now I need this area as well,
Yes.
right? So somehow I will try it. Here I have divided into two parts, one part. Now, if I will divide this same rectangle, this is the area. If I will divide this thing into two parts like this, and then I will divide like this. Here, one rectangle you got, you got the another rectangle. You can find area of this, you can find area of this, and if you will add the area of this both thing, you will get the more accurate area than this part, right?
Yes, sir.
Yes, sir. What was your motivation? Your motivation was to find this area, right? So what you thought, because you know only the area, how to calculate the area of rectangle. So you divide this by one rectangle, but you got this error, right?
Right.
Yes, sir.
Right. Now, what I divide this into two parts, and then I do this kind of thing. Then I got the error this and the error this. But what I have realized, I have observed that the error, the total error is less than this error.
Yes.
Right? Now, again, if I will divide it by 3 parts. Like this. And then see what will happen.
Sir, then we will get
If
more
I will,
accurate area.
yes, right? So whenever, so what I am doing here, I am approximating this curve by this rectangle, right?
Right.
Basically what I am doing. So if I will, like if I am increasing the number of rectangles, my area will become more accurate than the previous one.
Yes.
So that is the motivation of Riemann sum. Okay. Now, how will you calculate that kind of area? That we will discuss in the further discussion. Okay. So before discussing all those things, we will discuss. You all know what is interval, closed interval. This is what you are taking all those values of real numbers such that this thing you know, right?
Yes, sir.
Okay. So before starting that, one terminology is there, partition of interval. Of an interval AB. Okay. So what is the dictionary meaning of this partition? Can someone quickly tell me?
Divide.
Dividing something, right? Dividing something
Yes.
or anything. I am not moving
Cut
so
in
fast because
pieces.
is it okay for you in this speed?
Yes, sir.
Yes, sir.
Please give me some time so that I will explain in a more accurate way, so that you will understand the concept in a deeper way. Okay. Please give
Yes,
me some time.
Yes, sir.
Okay. So what does it mean? What does this partition mean?
a cut in piece.
Yeah. What kind of pieces it will? Okay. Suppose there is a family. There is a family. Can you please, Vivek, can you please mute yourself? Okay. Suppose there is a family here. Father is there, and this father has 3 sons. Okay. Son 1, son 2, son 3. And he has some property, 100 acres. 100 acres land. Lands this father has. Now, after the death, when the father is died, this property will distribute to this 3%, right?
Yes, sir.
Right. So in this case, how will I distribute? Suppose I am giving, say, 60 acres to this, 20 acres to this, 20 acres to this. Okay, so what kind of distribution it is? If this is the 20 acres land, so I am distributing 60 to S1. Okay. And 20, right?
Yes, sir.
20 to this S2. This is suppose S2, this is S3, and this is S1. That kind of partition it is. So in this case, if the S2 person is taking some land, does the S1 person is taking? It means that if this land is set A, this land is set B, this land is set C, I am saying, is there any common thing in between this A, B, and
No,
C?
sir. No.
No. It means that A intersection B, B intersection C, and C intersection A, all are empty, right?
Yes, sir.
Yes, sir.
That kind of partition is here. It means that there is no overlapping kind of thing in this partition.
Yes, sir.
Similarly, if you need to if you want to partition this interval AB, suppose this is A, this is B, what you will how will you partition? You will partition into some small intervals. right? Like this.
Yes, sir. Yes.
Like this. Okay, suppose this is your x1 point, this is your x2 point, this is your x3 point, this is your x4 point, and this is your x5, and the initial point is your x0. Okay, so this collection, so rather than writing by this manner, x0 to x1, then x1 to x2, and then x3 to x4. Rather than writing this manner, I can directly take this point only, x0, x1, x2, x3 up to x5, right? We can understand, yeah, the
Yes,
partition
sir.
is like this. So this P is known as, this P will become partition of an interval AB. Okay, when, so here what is the property of this xi? This xi is xi minus 1 is always greater than xi. It means that x1 is greater than x2, x2 is greater than x3. This kind of thing is happening here. In a way, you can say x0 is greater than x1 is greater than x2 is greater than x3 is greater than x4 is greater than x5. This kind of thing is happening here, right?
Yes, sir.
Right? So when a set P, this P is equals to x0, x1 up to xn is said to be where all the xi's are coming from this interval A, said to be partition of AB if x0 is equals to A, xn is equals to B, and xi minus 1 is less than xi. It means that this kind of thing is happening. Getting? Got the point? What is partition?
Yes, sir.
Okay. Now, basically, what you are doing, you are dividing interval like this, xi minus 1, xi. You are dividing this AB to this kind of thing, right? Like this, x0, x1, x1, x2. If your I is equals to, like I is equals to 2, you will get this. I is equals to 1, you will get this. You are getting my point?
Yes, sir.
It means that there will be some length. There will be some length. What is the length of the interval? The length of the interval is nothing but b minus a, right?
Yes, sir.
Right? That you have learned now. What is length of the interval?
Yes, sir.
Yes.
Okay, so it is b minus a. It means that for that, what will be the length? X1 minus x0. For that, x2 minus x0. Right? For this interval, what will be the length? xi minus 1.
Yes, sir.
Okay. So this length denoted, it is denoted by del xi. This is we have considering. Okay.
Yes, sir.
Okay. Now, since I got what? I got a different collection. Del x1, del x1, del x2, del x3, and up to del xn. I got this collection, right?
Yes,
Right?
sir.
This is all what? This is all the length of subinterval of a partition, right?
Yes, sir.
Now, in this case, since I am dividing this interval AB by this kind of thing, so there will be some biggest length, right? Like this. There will be some biggest, there will be some maximum length. Maximum length. There will be some interval which length is maximum to all of these subinterval.
Yes.
Right? So that maximum length is known as norm of P. Okay, this norm of P is nothing but maximum of all the del xi's.
Yes, sir.
Got it? This is just a notation of norm of P. And this is what? This is a partition. What is the norm of P? The maximum length of the subinterval. The maximum of del xi. Got it?
Yes, sir.
It means that suppose this is some del xk. Kth interval has the maximum length. It means that this will be the maximum. This will be the maximum value for this set. It means that all the length will be lesser than this value. Get it?
Yes.
Got it? Now, again. So, if you are del xk and if what is this? This is non-p will go to 0. If this length will decrease, it means that this will go to 0. All the del xi will go to 0 because this is smaller than del xk.
Yes, sir.
This is the maximum one. If the maximum is decreased, if the maximum one will go to 0, this one will go to 0 because this is less than this. Right?
Right.
Right? So why I am saying this, I will let you know later. Okay. Now, understood up to this partition and norm?
Yes, sir.
Now, what is Riemann sum? What is Riemann sum actually? So Riemann sum is nothing but Riemann sum is S of function f is nothing but it is denoted by sp and represented as like this. fxi star del xi. What is this? I will let you know later. Okay, just a minute. Sorry, xi minus 1 xi. Okay. So what is this actually? So let's move to that particular thing. If this is your A, this is your B. So I need to calculate the area of this function. Okay. So let's move in here. So what I did, I was doing, I was just breaking this point. If this is A, this is B. So what I am doing, I am introducing here some x0, right? Some x1 point here. Here I am introducing, if this is A, this is B, I am introducing some x1 and x2.
Yes.
Right? If I will increase this thing, it means that I am introducing some point in between this A and B. It means that what I am doing, essentially, I am partitioning this interval, right?
Yes.
In a way, if I will able to see, I am doing nothing. I am just partitioning this interval. By here I did 3 parts. Here I did 4 parts. Here I did 2 parts. Here I did 3 parts. That kind of thing. Or further, I will did 4, 5. I will do 4, 5, 3, 4, 4, 5, 6, 7, 8 like that.
Yes, sir.
Right? But after each partition, your norm P is going lesser and lesser, right? Suppose P1, this one is your P1 partition, this is your P2 partition. So this kind of thing is happening because this distance is decreasing, right?
Yes.
Right? Now, what is this x star? I will let you know. Suppose I have did this partition. Okay, let me define the function in a more precise way. Okay, this is your function. This will be easy to explain. Now, same thing. Either we can calculate like this, like this. So this will become your area, right? Right? This answer.
Yes,
So
sir.
in this case, if this is your x0, this is your x1, this is your x2, this is your x3, this is your x4, this is your x5. So what will be your area, total area? This area you need to calculate, right? this area. So for the first one, what will become your area?
x1 minus x0.
F of A into del x1. This distance is del x1 and this distance is f of A, because you are taking this only.
Yes.
Right? For first one. For the second one, what will be your area? For second one, it will be this height is what? This height is what? This is your fx1. So this height is what? fx1 into del x2. Like this height is fx1 and this width is what? Del x2.
Yes, sir.
Right? So the area of this is what? Del x2. But I need similarly for this case, what you will get? F of what? F of x2 into del x3. In this case, what you will get? F of x3 into del x2, sorry, del x4. Similarly, f of x4 into del x5, right? So you got the area of this. Now you need to combine all those areas. So what you need to do? You need to add all of those area. Right?
Yes, sir.
Right.
Okay. Okay. So this is what? This is basically nothing but f of xi minus 1 into del xi, right? Where I is moving from 1 to 5.
Yes, sir.
And here you are taking functional value of the, if you are taking, your interval is this, you are taking functional value of the left side entry. This is what? Functional value of this entry, right? For the ith interval. This is what? This is nothing but your x0. It means that in the interval x0, x1, this is the functional value of x0. In this case, this is the value of x1 in this interval. See, in this interval, this is what? This is the functional value of the first entry. Here, in this case, this is the here fx2. This fx2 is what? The value of this lower one, right? The first one, the first entry in this interval. You are getting my point? It means that in the ith interval, this is your ith interval, you are getting what point? Xi minus 1. It means that the first point, the value at the first point. Getting my point?
Yes, sir.
Okay. So this is what? So this thing is known as lower sum. Okay. If you will take this as n, if you are participating our interval as n parts. So this thing is known as lower sum. Why it is known as lower sum? Because in the ith interval, you are taking functional value. You are taking functional value at the first part, at the left part, at the lower part. This is the lower value than this, right?
Yes, sir.
Yes.
Okay, so this thing is known as lower sum. Okay, okay. Now again, same example. Now, anything is tough up to this?
No, sir.
What? Just a minute. Huh? Okay. So suppose this is your function again. Again, I am doing same thing. But in this case, I am doing in a different way. Okay. Okay. For this case, I was doing this thing. Here I am approximating and I know what will be the area of this all the rectangle. That area will be less than the original area, right? Right? Right?
Yes,
The
sir.
present area will be less than the original area.
Yes, sir.
Right? Now, I am saying, where is the graph? Okay. On that thing, I was taking this thing. Right? But I can take this thing also. Right? Right? So what I am doing here actually. This marker is. This thing is not working. This eraser is not working. Okay, let's make a different. Okay. So rather than doing this thing, the lower part thing, I can do the upper part thing, right? I can take the functional value like this, right? Like this, like this, like this. So in this case, whenever, in this case also, whenever I will increase the number of this partition, this will be the error, right? This error will be decreased, right?
Yes.
Right? The error will be decreased for this case only. So here what I am taking, I am taking the, if this is your interval, if this is your interval, I am taking this value. That's the whole thing. This thing is what? The functional value of at this point, right? X1 at X1. This is what? At X2. So for first interval here, I am taking the upper value. I am taking this functional value fxi. Right? So in this case, this is known at, well, in this case, how will you write the, this is what? Right? This will be look like this. Or you can, if you want to see explicitly, it will be look like del x1 dx1 plus fx2 del x2. Like this. Like this, it will be look like.
Yes, sir.
It will be look like this only, because I am taking the right portion. I am taking the larger one. Right? Functional value of the larger part. This thing I can take for approximating the area. You are getting my point?
Yes, sir.
Okay. So in this case, this is known as what? Upper sum. Okay. So in the question, they will give you the partition. Okay. They will give you the partition and they will ask you what is the value according to this partition. According to this partition, what will be the value of lower sum and what will be the value of upper sum? Now, you will be able to find the value of lower sum and upper sum.
Yes, sir.
You need to just partitionate this and then go by this two formula. Where is the... Okay, go by this for two formula. Okay, you will get your upper sum and lower sum. Now, again, I am talking about the approximation of the area as well. I am still talking about the approximation of area. Now, someone will come to me and then they will ask me, sir, why are you taking that lower value and upper value? Why you are doing like that? You can take any value from this interval, right? If you will take any value, you will have some functional. Suppose I have taken this value. So I can take like this, right? Then error will be this and this. You're getting my point?
Yes,
I can take like this. I can take like this. Then error will be this and this. It means that I can take any arbitrary point x between this sub-interval line, right?
Yes.
So
Yes.
for the ith interval, xi minus 1, xi, I am taking this xi star as arbitrary point. And then see, I will see xi star del xi. This will also give me the approximation of the area. This will also give me the approximation. This will also give me the area of the rectangle, right? Because this is also the area. This is also a rectangle, and this will also give me the area.
Yes.
Right. So in this case, what will you get? You will get this fxi star del xi, where xi star is coming from what? Xi minus 1 xi. Right? And this is what? This is your Riemann sum. This is nothing but this is your Riemann sum that I have written here. See? So in this case, they will ask? They will ask you find the Riemann sum of this function given this partition. So you will be able to find this Riemann sum. You have to take any arbitrary point. Even this is also a part of Riemann sum only, because you can take any arbitrary point, and here you are taking the left hand point of the interval. Here you are taking the right hand point of the interval. So this is also a Riemann sum. Okay. So this is first one is known as lower Riemann sum, and second one is known as upper Riemann sum. Now, understood the concept of Riemann sum and lower sum and upper sum, what is it?
Yes.
Yes, sir.
Now, if I need to find the area of this interval, area of this thing, so how will I know? So I have this norm P, right? This is the maximum. This is the maximum del xi, maximum of del xi, right? So what I know, if I will decrease this maximum length, it means that if I will take more and more, if I will take more and more partition, it means that I am decreasing this norm, right? I am decreasing the maximum length. Then I will able to get the area. I will be more approximate this area by this rectangle route, right?
Right.
Right. So basically, what will be the area? The area of that function is given by limit of norm p goes to 0 of sp, which is equal to nothing but limit norm p goes to 0 fxi star del xi. This is only. Got my point? See, in your notes, they have written norm p goes to infinity. That is incorrect, okay? That is incorrect. In your notes, they have written this. This is incorrect. Here you have to take norm p goes to 0. You don't want norm p larger and larger. Okay? You need norm p 0, tending towards 0. Why I am tending towards 0? Because I need to make this norm p. It means that the maximum length of subinterval as 0. It means that it will become, if it will be 0, it means that the approximation will be more accurate.
Yes,
you got my point? Okay.
Yes,
and this thing is represented as like this. Okay. And this is also known as definite interval integral. Definite integral.
Yes.
Got it? Okay. So what I have covered till now? This one is done, this one is done, this one is done, this one is done. Okay. Definite integral is not nothing but the area of area under the curve, area of this. Okay.
Yes.
Okay.
Yes, sir.
Now, antiderivative. Now, understood how we are calculating the area. Okay. Can someone tell me why I am using this sign only?
Sir, because we are integrating over the
We did not
range of
discuss. We did not discuss the integration thing to yet.
Okay, sir.
Here, there is no discussion of integration. Here, this is the definite integral. I am not talking about integration right now.
It is the
Sir,
sum.
we are adding all the intervals from A to B, collective sum of those interval, which is also denoted by this symbol.
So basically, from where this single is coming, uni S means what? Sum, right? So just stretch like this, you will get this symbol. No rocket science is here. Okay, this symbol is coming from this sum part, because here I am summing the intervals. Okay, that is
Yes,
the
sir.
theory, and this theory is given by Riemann sir, the legendary person of mathematics. Okay, this is just for general information that I have given to you. So okay, so antiderivative. What is antiderivative is basically, so an antiderivative of the function f is a function capital F. Here I am using small f, here I am using capital F, defined on the domain D, such that if you will differentiate this function, then you will get fx for all x belongs to D. Means that if there is a function f, capital F, for this function, if there is a function capital F for which the derivative function of this function will become your f, then this capital function is known as antiderivative of f. Got it?
Yes, sir.
Okay. Now suppose I am giving you an example for x plus 2. So what will be its antiderivative? Capital F x. It will be your x square by 2 plus 2x plus c, right? Why? Because if I will derivate this function, what you will get? So this will become your x plus 2, which is your fx only.
Yes, sir.
Right? So this will become your derivative. But here, in place of c, you can take any value. Any constant value, you can take 1, 2, 3, 4, 5, whatever you want. You can take any real number. It means that the antiderivative function is not unique. Function is not unique, right?
Yes, sir.
Right? And also, if f is your antiderivative function, then f plus c will become also antiderivative function, right?
Yes, sir.
These all the things are observation of antiderivative. So understood the concept of antiderivative?
Yes,
So
sir.
basically you have to integrate the thing. So this antiderivative is known as integration. So for calculating the antiderivative thing, you need to calculate the integration part. Okay. Now you are getting the point where the integration part is coming.
Yes, sir.
Okay. Okay. After that, fundamental theorem is coming to the picture. Okay, so this thing I will explain by the PDF because I don't have notes for that. So let me open the PDF, then I will explain. Is it okay for you?
Yes, sir.
Yes,
Carry
sir.
on, sir.
Yes.
Because this is not so tough. This is so easy part, the easiest part of the whole thing. Just a minute. Okay, it will take less time as well. The hardest part I have already explained.
Yes, sir. Go on.
Okay, just a minute. Let me see. Are you able to see the screen?
Yes, sir.
Yes, sir.
My cursor is visible. So what is the fundamental theorem? The fundamental theorem is saying, suppose f is a continuous on domain D, which includes the interval AB. Okay, let me download it and then I will let me download it. Okay, just a minute. Here I am not able to write, right? Now, are you able to see this H?
Yes, sir.
Now, here I will be able to write actually. Okay. So what is this? Suppose f is a continuous on the domain. It means that whatever domain it is, your f function will be continuous on this domain, which includes the interval this. It means that this AB interval is a subset of this thing. Okay. Then an antiderivative of for f on AB is given by this function. See this function, and this is nothing but this is known as indefinite integral. Or you can say, if this a is nothing but if this a is coming from minus infinity. So, or you can say integration. Okay.
Yes, sir.
Got it? So, for by this manner, you can calculate this fx. And how will you calculate this? You have the way, right? By Riemann sum or by that particular thing I have already explained you. Or further, you will be able to know by this kind of formula, that you have. By this formula, you will be easy to integrate the function. Okay, you will be able to integrate the function. So conversely, if f is continuous on the domain D, which includes interval this kind of thing, and f is the indefinite integral. See, indefinite integral of f, then the definite integral from a to b. Here we are calculating a to x. Now the definite integral of a to b is denoted by this only. Okay.
Yes.
Okay. So this is
Yes,
what
sir.
actually, if I have some free space, I will explain. Okay, here. So what you have right now, a to x fx dx. This is your fx, right?
Yes, sir.
Right? What you need to calculate, a to b fx dx. That thing you need to calculate, right?
Yes.
Yes.
Sorry.
Thank you very much.
So if you will calculate this, you know this is what? Why so? Okay. So integrate it. What will you get? You will get capital fx from a to x, right?
Yes, sir.
Right?
Yes, sir.
Okay. So this is nothing but this will be your b in this case. So here you will take b.
Yes, sir. Got
right? Because this antiderivative thing is not fixed. That is why here you will get some fa, which is nothing but which will be equal to c, your constant c. Okay, but in this case, that c will be cancelled out.
Yes, sir.
How it will be? Suppose fx is equals to x is your example. Okay, now you need to calculate this a to b, fx dx. Okay, in this case, what will be your antiderivative function f? It will be your x square by 2 only.
Yes, sir.
Right? Now, if you will integrate in the definite way, what you will get? You will get x square by 2 plus c kind of thing, a to b.
Yes, sir.
Right? Now, if you will calculate further, what you will get? B square by 2 plus c minus a square by 2 plus minus c. Then this c will cancel out, that extra term will be cancelled out.
Yes, sir.
You're getting my point? It means that what you will get in general, b square minus a square by 2 only.
Yes, sir.
So this is what? This is nothing but your fb minus fa, right?
Yes,
Because
sir.
your
Yes,
f
sir.
is like this. So this is the only that, this is the thing that this theorem is saying. Got it?
Yes, sir.
Okay. So here are some tables. You just take a screenshot, or I think you have. This will be very important for you for calculating the integrals. Okay. This kind of thing. Just take a screenshot of these tables.
Yes, sir.
Okay. Now let's move to the one note again. Okay.
Yes, sir, complete, sir.
Sorry. So I am inserting such formulas. Trigonometric is done, right?
Yes, sir.
Actually, I have downloaded some formulas. Okay, this is okay. Just see. These are some formulas for differentiation and integration both. Okay. You can take a screenshot of those formulas. Or I will share these notes to you guys. If I will share here from here, if I will share by chat box, you will be able to download.
Yes, sir.
So I will share by
Yes,
chat
sir.
box. Okay, I have shared this thing in chat box. It will got it? Received?
Yes, sir. Receive.
Okay. Okay, fine. Let me think what remains. Nothing is remains, I guess everything is covered. Okay. So some of the identities are there, like so these are the basic properties that you have, basic properties of integration. So you will be see, you can see like this, right? This is just a scalar multiplication, addition, and multiplication kind of thing that I have already like for covered in
Yes,
the
sir.
differentiation part, in the limits part as well. All of these same. Okay, how will you integrate by part? How will you use? Then this is the substitution method. After that, you have some substitution method. Let me see. Let me think. Okay, these are the some basic properties that you can learn by yourself, right?
Yes,
You
sir.
can learn, right?
Yes,
Okay.
sir.
So this thing I don't need to. Okay. So integration by part is there. And after that, how will you calculate the integration by substitution? This is also easy. You can calculate, right?
Yes, sir.
No need to explain this thing. This thing
No,
is
sir.
already covered in your +2 course or in your class 12th.
Yes.
So is it necessary to compute this thing? What are the important thing? I have already covered it to you.
Okay, sir.
Okay, this is important, but this is easy. That thing you can do by yourself only.
Okay, sir.
Yes,
So shall I leave this?
Yes,
yes, sir.
sir.
Okay, okay, okay. Thank you. Okay, you can leave the class. Okay.
Sir, is there any class tomorrow?
No, for my class will be not there. Okay, this was my last class, I guess.
Thank you so much, sir. You have invested your 4.5 hours without
It's
break
okay.
for
It's
us.
okay.
Thank you so much, sir.
Thank you so much.
Okay, okay,
So
Sir,
it
okay,
was the
okay.
class.
these 3 days have been very good, sir. Thanks so much.
Thank you for you. Thank you
You took a
for.
lot of pain, sir. Seriously. Thanks.
It's okay. It's okay, guys. Sir, could
Thank you so
you
much, sir.
please provide Excel sheet of all session links? See, Siva, I cannot provide this thing. You can ask for this thing. You can ask for the TAs so that they will have some links. I don't have. What I will do, like they just tell me today's you have session and then I will take session. That kind of thing I will do usually. I don't have that kind of link. You can ask some TA, okay, Siva, or you have so many friends in this chat box. You can ask to them if they have, they will share it. Like you have some WhatsApp group kind of thing also, right?
You
Right?
can
Sir,
ask
can you
in your
please send
group,
the
sir.
season PDF in the chat box? Is it
This
possible?
PDF, this PDF. Let
Yes.
me let me see. Let me see it is possible or not. If it is
Yes, sir.
possible, I will, because I did not try it
Yes, sir.
before. Actually, this this PDF, this will not going in PDF form. This is going with that OneNote form. So if you want to open this, you need to open by OneNote only.
Oh, okay, sir.
So I have one out tab, sir.
Huh?
The one
Sorry.
out, sir.
I don't know, but like I have shared this thing in to some of the student. They was like, sir, I'm not able to open this thing. So I recommended that please use OneNote for that. Okay, so I'm trying to. Where is the document? OneNote section 12. It did not download actually. Just a minute. Okay, I am trying. This is meant to be solution. Something. I have sent it. It will take some time. So how is going your preparation? Oh,
Sir, it was good. It is going good.
it's going good, right? Okay. So how was the class?
Fantastic, sir.
Okay. So I have sent that document. Just check it once, whether it is opening, whether you are able to download. Sir, tomorrow there is a session. No, Bhanu. There is no session for tomorrow. At least my session will not be there. Okay.
Same session, sir.
Yes.
Okay, one more file that I have for day before yesterday's session, week 1 to 4 slides. That also I will share, or
Yes, it is accessible.
I will share that one also. This is the great thing actually. New session cannot be sent because it has been modified. Hmm. Okay.
So the PDF is open, sir.
Just a minute, I don't know what thing is happened in my laptop. It's not opening actually. Yeah. What do you want?
It was open, sir.
Open, right?
Yes, sir.
Yeah, okay, fine. In a PDF form or in OneNote form only?
In OneNote form, sir.
Yeah, okay. Okay, just a minute, I will share that week 1 to 4 or 15. I have shared that section 15.
Thank you so much, sir. Good night.
Okay, good night. Okay, I have shared that week 1 to 4 PDF as well. Okay, you can see. So if I will end this class, that chat box will be closed, right? Or this will be,
No, sir, it will close, sir.
it will close, right? So I have to
Yes, sir.
wait for some time.
Okay, sir.
Okay, please quickly download it.
Yes, sir, completed.
Completed, everyone? Sir, have you done any session? No, no, no. I will not going to done any session for week 10, 11. So you have up to week 11 or 12 will be 12 is also there. Up to week 11 only, right? 12 begins.
So 12 is
No,
only
no.
revision up to week 11.
I think tomorrow morning there is a session.
Okay, okay. I don't have any idea about it. There will be some session or not.
Calendar.
But yeah, I will not going to take that 11, 10, 11, 12 session because I did not learn that graph theory portion in my course. So I don't have any idea about it. But yeah, I am learning. I am in the learning phase right now. So that is why I will not going to take. Maybe Suham sir will take that session or Vishal sir. I don't know. Okay,
Sir,
shall I leave the session?
yes, sir.
Someone is downloading. If downloading is complete, please let me know.
Yes, sir.
It's
Completed.
Others can
completed, sir.
leave. Completed. So shall I leave the session?
Yes, sir. Thank you, sir. Bye, sir. Good night,
Yes,
sir.
sir. Thank you, sir.
Okay, good night.
Have a nice day,
Good
sir.
night. Good night. Good
Good night.
night. Good night.
Good night.
Thank you,
All
sir.
the
Good night, sir.
best,
Bye, sir.
guys.
Thank you,
Thanks,
sir.
All the best.
Thank you, sir.
All, all the best for your exam.
Thank you so much,
Thank you
sir.
so much, sir. Good night, sir.
Good night, sir.
Good
Bye,
night.
sir.
Good night. Bye.
Bye, guys.